Hello dear students, in this lesson we'll talk about version control systems. We are going to discuss why do we need them. I will give you the list of the most popular version control systems and we will focus our attention on Git. Why we have to learn it. And at the end of this lesson I will give you a short overview of Git features and how it operates. First of all, Git, the same as other version control systems, is not a programming language. You might be wondering, then why do we need to learn it? It is pretty common that multiple software engineers work on the same program simultaneously, or different versions of a program are deployed on different environments. Thus, team needs to have some tool that will allow them to track changes in the source code, configuration files, and sometimes documentation. For example, each engineer may have archive with the source code and after that team members have to merge code somehow together. While this approach might work, it is extremely inefficient and doesn't allow to track changes closely. Also, for the purpose of finding, localizing and fixing a defect in the code, it is critically important to compare different versions of the code to identify where exactly bug appeared to fix it. That's why we as programmers should know how to use version control systems. Let's quickly discuss what the most popular version control systems are. They are Bazaar, CVS, Mercurial, Subversion, Git. And according to this survey, Git is used by almost a million of people who took part in this survey. Definitely, Git is the most powerful and popular version control system nowadays. That is the first reason why we are going to learn Git. The second reason is the fact that knowing how Git works, it would be like a piece of cake for you to understand how other control version systems work. Every job description for software engineer requires from you knowledge of Git because of its popularity. As you might already understand, Git is a program which is used to track changes in the source code during the development, but it can be used with any type of files. Right now, we'll do a high-level overview of the Git. I will tell you key features and basic principles of how Git operates. The key difference between Git and other version control systems is that Git doesn't store differences in files. It stores links to the snapshot of changed files. In case file wasn't changed, Git doesn't store this file again. Instead, it stores just a link to the previous identical file that was already stored. So, each time you commit changes, Git takes a picture of what all files look like at the moment and stores a reference to that snapshot. This is an important distinction between Git and other version control systems. Another important Git feature is the fact that you can't do anything without Git knowing this. Before snapshot of your file system is created, everything is checksummed and hash is created. Afterwards, you can use this checksum to refer to this exact state of the files. That means it is impossible to change the contents of any file or directory without Git knowing about it. So, each your commit has 40-character string composed of hexadecimal characters and calculated based on the contents of a file or directory structure. Hash looks like this. And you can use this hash string to navigate between different versions of your code. Version control systems might be centralized and distributed. In centralized, all engineers are connected to the main server and all people collaborate through that server. The biggest drawback here is the fact that when central server is down, you can't collaborate. In distributed version control systems, each engineer has a copy of the whole project and can easily restore it if needed, or in case there is no network. Git is a distributed version control system. To perform most of operations in Git, you don't need information from another computer. That's why there is no latency overhead when you work with Git. You have entire history of your repository of all changes right on your local computer. You have hidden .git folder that contains all information about the repository and you don't necessarily need internet connection to perform some operations with Git. If you are in airplane and you want to do some coding, you can do that and successfully save all your changes. You can also navigate in the repository of your project and navigate to different versions of your code while being offline. For example, in Subversion and CVS you can edit files, but you can't save changes to a database just because you're offline. It doesn't seem to be a huge problem though, but probably in real world you won't love this. Having all repository history on your local computer gives you instant access for all changes. That also means much better performance. Before we get deeper to Git program and Git commands, I want you to understand basic principle of interaction with Git. This will help you to understand our next lessons. All your files, according to Git, can be in 3 different states. Modified, that means you modified the file, but you have not committed your changes yet. Staged, this means you have marked a modified file to be present in the next snapshot of your file system. Information about such changes is placed in the file with name index. That's why during the course sometimes I'm going to say add file to stage or add to index. And you will understand that this means the same, because all files from staging area that are marked to be present in the next snapshot are reflected in index file. Does it make sense? And the third state is committed. This means that date is safely stored in your local database. We can say that you have working directory, that is set of files you work with. The staging area is the index file, and hidden.git folder is a folder where Git stores all data about your project, including database for your project. So your basic interactions with Git are going to look like this. You did changes to a file or to a set of files, you add those files to index, you committed changes and you create snapshot of your files. That's it. Let's recap what we have learned today. Today we learned why we need version control systems. Now you know the most popular version control systems and you know that Git is the most popular VCS. You learned key features of the Git and understood how Git operates. I believe now we are ready to proceed with our next lesson. Hello dear students, in this lesson we are going to learn how to create a local repository and how to make your first commit. First of all, I want to say that there are 2 ways to create repository. The first one is to create the new one locally. The second option is to clone existing repository. In this lesson we are going to cover only the first option, and the second option will be covered in other lesson when we'll learn what remote repositories are. Our goal during this course is not to learn thousands of fancy Git commands that you won't use. Instead, we are going to focus on practice and learn everything what you need for your current or the future job. That's why most part of the lesson we'll spend practicing real-life scenarios. I will show you such main commands as git init, git add, git commit, and git status. Also in this lesson I will tell what a branch is. We'll discuss different cases when to use different commands with different attributes. Let's start, and the best way to understand this topic is to practice. We are going to start from the creating Git repository locally. Here is our demo project. Imagine that we have some source code here in src folder. Here in bin folder we have compiled binary files. And we want to use Git to track changes in these files. Let's open Git bash here first. Now let's initialize the repository. Let's perform git init command. Type git init and press enter. Now you see that in parentheses there is a new word, master. Master is the main branch. What is a branch? Branches in Git are a part of everyday development process. Each branch contains a history of snapshots. Technically, we may call these snapshots with other words. Those are our commits. During the development, we'll switch branches to separate development of a new task or a new feature, and after that we'll merge branches. Master is our single and the main branch which we have right after repository creation. How to do operations with branches we are going to learn in the next lessons. After we executed git init command, .git folder was created in our project. It is hidden by default. So make sure you enabled view of hidden folders, and here it is. You don't have to change files here manually. Just in case you are interested, you can investigate how Git stores configurations and history of the project. Now, when we have Git repository initialized in our folder, we want to track changes in existing files. The first thing that you need to understand in this lesson is that files can exist in one of two states: tracked and untracked. In short, tracked files are files that were present in the last snapshot of your files. Those are files that Git is aware of. Untracked files are files that are present in the working directory but that were not in the last snapshot and are not in the staging area. To tell Git that you want to track changes in file, we need to execute git add command. Git add command adds files to the staging area. Do you remember first lesson when I told you about staging area? That's the area where we place files that we want to commit. We can add one file or multiple files. For example, to add one file, I have to write the following: git add license.txt. If I want to add multiple files, I can type space and type new file name. For the sake of example, let it be readme.md. Now you can press enter. To check what is the status of your repository, on which branch you are and whether there are stage changes to be committed, we have to type next git command, git status. Here I can see that 2 files were added to staging area, and the rest of the files were not, including all files that are in directories bin and src. To clear git bash console, you can press Ctrl and L simultaneously. Now it is much better. We can add multiple files with the help of the mask. For example, if you want to add all files with Java extension, I need to type the following: git add *java. Asterisk here means files with any name but that has Java extension. Let's press enter. We see here that line feed is changed with carriage return and line feed characters. Let's now check git status. I use arrow up key to check commands which I recently entered. Here is a git status. I press enter, and you see? Now Java file is also added to the staging area. By the way, in case you don't like such verbose status, you can use short version of git status. Git status -s. You can see that there is a letter with the status. Either files are added to the staging area, modified, and not added. If we want to add all files, we can just use dot like this. Git add dot. Here dot means all possible names and extensions. And if we would check git status now, we are going to see that now all files in my project are ready to be committed. Now, when all files are in staging area, let me commit these changes. We have to type the next command: git commit -m init commit in quotes. M flag in this case stands for message. Each snapshot of our file system should have message. Usually this message is used to describe the changes that were made in scope of this commit. You can use -m flag because it is very convenient to leave commit message in line with commit command. In case you forgot to specify .m flag, the default text editor will be opened. Let's use inline message command. Usually the commit message of the first commit is init commit. Press enter. Here you see that Git created a snapshot. Let's check status. And you can see that there is nothing to commit because there were no any other changes from the last commit. Let me clear console. By the way, in case you forget any command, you always can ask Git to give you a hint. There are 2 options. The first option: type help after a command that you want to use. For example, git status --help. And you can see that page from manual is opened automatically in your web browser. Here you can find command description and all possible options how you can use this. The second option is to type shortcut from help like this: git status -h. And you're going to see a list of options that you can use with this command right here in console. One more thing that I wanted to show you in this lesson is how you can combine adding to stage and commit in one command. For example, let me do a modification in one of the source code files. I will add one more space in some line. Let's check short status. And we see that we have one file modified. Let me commit this file and adding it to the staging area simultaneously. Just type the following: git commit -a-m new changes and press enter. Git automatically staged every file that is already tracked before doing the commit, letting you skip the part where we have to add files to the staging area and perform git add command. Okay, now let's recap what we have learned today. Today we learned how to create local Git repository. You know what a branch is. Today you also understand the difference between tracked and untracked files. Together we told Git to track files and added them to the staging area. Now you know how to commit snapshot of your files. And also we learned how to request a hint from Git and how to use help command. That's all for today. Thanks a lot for your attention and see you in the next lesson. Hello colleagues, in this lesson we will talk how we can ignore files from Git tracking and how to untrack files if we don't want Git taking snapshots with these files. After today's lesson you are going to learn what is a gitignore file and what should be placed there. Also, I am going to show you commands that will help us to untrack files or even the whole directory with files in it. To make sure that we can check commit history in console, we will learn today git log command and main attributes that it has. Let's start. I will show you Git examples on our demo project. To start the lesson, I want to ask you a question. What files you would like to track with Git? Technically, you can track changes in any file, but does it make sense? Not always. In software development there is a sense in tracking changes only in the source code and some configurations files. There is no need to track files that will be generated again during the program compilation like these binaries files in Java. Also, there is absolutely no sense to store environment-specific files like this class path file, because colleagues of yours may use different development environment and they wouldn't need these files at all. Now, when we know this, we understood that in previous lesson we did a mistake. Don't worry, we did that mistake on purpose so that you could learn additional important Git commands just in case. Imagine that you realized that you don't want to track changes in the binary files and this class path file, because it is specific only to the special program and have nothing in common with your source code. What to do now? We have to tell Git to not track changes in that files anymore starting from today. How to do that? I don't want simply remove file. That is the easiest way. I want just to remove this file from the Git staging area, but I still want to keep file in my working tree so I could keep using this file. To remove files from Git but still to keep them on the local machine, I have to use the git rm command with cached attribute. Let's remove this class path file. Type the following in git bash: git rm --cached .classpath. .classpath is the file name. And you see, classpath file is still present in my working tree, but it is marked as removed for Git. Let me show you this in git status. Here you can see that our classpath file is mapped as untracked and deleted from the staging area. Important thing for you to remember: in case you will not use cached flag, you will remove file from your file system too. Cached means to keep file in your working directory, but remove it from Git staging area to not track it anymore. Does it make sense? Now let's discuss what to do in case you accidentally added to the staging area all files from the directory, because removing files from staging one by one could take a lot of your time. So, in case we wanted to remove from the staging area all files from specific directory, we have to use R flag. R stands for recursive. With this flag, all files from the specific directory and from internal directories within that directory will be removed from the staging area. Let's type the following: git rm -r --cached bin /. Let's check status. Awesome! Class pass file and all files from bin directory are excluded from the staging area. Now I am under the risk to add accidentally those files back to the staging area during the next commit. To avoid this, let me tell Git to ignore these files and directories. To tell Git that I want to ignore something, I have to create special file without name and with gitignore extension. To create file from the git bash console, type the following: touch.gitignore. Touch command in all Linux terminals allows you to create a new file. Now you can open this file in any text editor or even here in console. For example, now you can find gitignore file here and you can open it in Notepad if you wish. But I will teach you how to impress your girlfriend or boyfriend. I will show you how you can use your console to edit text files. You can do almost everything with the help of console. You just need to know what to do. Type in console nano.gitignore. Nano is the name of the text editor program for Unix-like computing systems which can be used with the help of command line interface. Now we can add any text to this file. We can use patterns here. For example, *.class. This will tell Git to ignore all files with any name but with class extension. In our particular case, we want to ignore all files in bin folder. Then let's write bin /. And we want to ignore classpass file. So let's type .classpass. This is enough for us. Now let's save this file. In regular text editor you can press Ctrl+S buttons. Here we need to follow hints that are written down right here. To exit Nano text editor, I have to press Ctrl and X simultaneously. It asks me whether I want to save the file. I click Y button. Now it asks me to check the file name. I keep it the same, gitignore, and just press Enter button. Awesome, now we have gitignore in our repository. Let's check the status. Do you see the difference now? Git just ignores that directory and files. Git even doesn't tell me that bin directory or classpass file is untracked like it told me before. It just ignores these files. By the way, GitHub has a collection of gitignore files for different programming languages. I will leave this link in attachments to this lesson. In my opinion, these files are a good starting point for your own gitignore. But based on what I saw in these files, I can say that for many languages these gitignore lists are not completely perfect. Most likely you would need to adjust it in your project. But, as I said before, it is a good starting point. Now, when I'm totally sure that I ignored all files that I don't need, I can add all files to the staging area without any fear all the time. Usually I will use just git add command with dot like this. Git add dot. Because I added to the gitignore everything what I wanted to add. Now let's commit our changes. Always remember to write commit message that makes sense. In other lesson I will tell you best practices for writing commit messages so that each your colleague could understand your comments. Git commit -m added gitignore and removed bin from staging. Press enter. Cool. And the last thing I wanted to show you today is how you can check your commit history. You may want to investigate commit history just to check what happens and where you are in your project. To check this, type next command. Git log. Git log prints to you commit history of the current Git branch. In this case, this is commits of the master branch. And you see that from the first lesson we already created 3 commits here. By default, Git log lists the commits made in that repository in reverse chronological order. That is, the most recent commits show up first. As you can see, this command lists each commit with its checksum, the author's name and email, the date written and the commit message. There are numerous options for git log command. I'm going to show you only the most helpful options which can help you to get necessary information during the development. For example, you can limit amount of commits that you want to check. In case I care the most about last 2 commits, I have to type the following: git log -2. I believe you understood that you can change number to change amount of commits for view. Another pretty cool attribute is the formatting. For example, you can type git log _pretty equals 1 line, and you can see only checksum and commit message. There are multiple other attributes that can allow you to print commits following specific pattern, or to print commits that are related to changes in some specific directory, or show commits in specific date, but in my humble opinion, those options are not used in daily basis, because probably there is no lot of sense for you to print commits history in specific format, for example. But from previous lesson you remember how to use git help command to learn more from documentation. Meanwhile, we'll keep focus on the most powerful and useful commands that will help you in everyday activities. It's look like that's all what I wanted to share with you today. Let's recap what we have learned today. Today we learned a lot together. We learned how to tell Git to stop track changes in specific files or directories. Now we know how to tell Git to ignore changes in some specific directories. After today's lesson, you know how to create a gitignore file that will work for your specific project. And at the end of the lesson, we learned how to investigate our commit history. That's all for today. Thanks a lot for your attention and see you in the next lesson. Hello dear students, in this lesson we are going to talk about how you can undo things and adjust your commits, and we will learn basics of work in such console text editor as V. In this lesson on real examples I am going to show you how you can amend last commit, how to unstage files if needed. We'll learn git restore command and how you can use it to restore state of files. Also, I will show you how you can use tab for auto-completion in git bash to save your time on typing words. I will show you basics of work in console text editor V. And as usual, let's practice. I will open our project which we created. Okay, imagine that we did a commit, but we forgot to include one more file or another code change in that commit. We can easily amend the last commit. But be careful, today we are going to learn one of the few areas in Git where you may lose some work if you do it wrong. To amend changes we have to use the next command: git commit --amend. Amend option takes current staging area and uses it for the commit. In case you have nothing in staging area and the only thing you want to change is the commit message, then just use this command. For example, let me show you the message of our last commit: git log -1. Added gitignore and removed bin from staging. That is our last commit message that we did on the previous lesson. Okay, now let's change it. Git commit --amend. I add updated word at the beginning. Here text editor is opened. Just to remind you, Notepad is open because I set Notepad as a default text editor in global configs. Here I can change message. I press Ctrl and S to save the file and close it. Now let's check the last commit message. And you can see that message is updated. Just in case not all students changed default text editor, let me show you what potentially you can see. By default, Git bash uses vtext editor. So, in case you didn't change default text editor, you are going to see unusual for you text editor. Let me change my global settings to demo this to you. Git config --global core editor v. Now, let me amend commit message one more time. V is a very powerful program that supports many cool features. Unfortunately, this course is not about V. And I am not joking, it is really possible to pass course for V editor to learn more about it. But I will show you now the basics so that you could navigate here just in case you forgot to change default text editor. First of all, for cursor navigation you have to use next keys. L to move cursor to the right, J to move cursor down, H to move cursor to the left, K to move cursor up. V text editor has two modes, command line mode and insert mode. Let me show you on the example. Let me move cursor after updated word. Now I need to switch to insert mode. I need to press I key. And you see here in the bottom, we see insert word. That means you are in the insert mode. Now I can use backspace and other keys to change the message. Let me remove updated and write v-editor test. Now I have to save file and close it. To do this, I need to switch v-editor in command line mode. I press escape button. You can see that there is no more insert is written down here. To save changes and exit v, I have to type next, colon, W and Q. W stands for write, Q stands for quit. Press enter. Now let's check our commit message. And we see that commit message is changed. Awesome! Now you understand what I meant when I said that V text editor will be a bit unusual for you to use. That's why let's return back Notepad as a default text editor. Okay, now let's imagine you forget to add some changes. Let me add more spaces in the source code file. Then I add it to the staging area, git add dot. And now I want to adjust my last commit so that it includes the latest changes. And I don't want to change commit message. What I have to do? I have to perform next command, git commit amend no edit, and press enter. Here it is. Let's check our commit history. You can see that checksum is changed. This is important. Just remember that each time you do commit or adjust commit, checksum is changed. Later I will show you on real example why it is so important. Now I'd like to discuss with you next scenarios. Let me create new file. Imagine that we have some important configs. Let's create this file. Touch some important configs.txt. Also, I did changes to the existing source code. I'll put some new lines here. And I added all files to the staging area. Git add dot. Now let's check status. Git status. Here's a new file and here's the existing one. And I just realized that I don't want to have the one commit with changes in the hello world file and important configs together, because logically that should be two different snapshots. How I can unstage changes and remove from the staging area files that I don't need? Always remember to read git hints. Pay attention here. Use git restore --staged file to unstage. Let's follow this hint. Git restore --staged src/ and press tab key. Tab provides us with the auto-completion, so we won't waste our time on typing. Press enter. Let's check git status. And we see that hello world file was removed from the staging area and wasn't removed from my file system. Also, all changes are there on place. Perfect. I can create commit right now only with these changes. And after that I can add to the staging new file and commit it. Awesome! What if I want to discard changes? Let's follow hint from git here. To discard changes I have to type git restore and file name. Okay, let's do that. Git restore src/ and press tab to autocomplete hello world Java. And now we can see that changes were reverted. Great! The one thing why I like Git the most is that everything what was committed can be recovered. Even changes that were done with the help of git commit amend commands. Later in this course I will show you how you can use git reflog to restore literally everything what was ever committed. However, the changes which you discard without committing is not possible to restore, so be very careful. That's all what I wanted to share with you today. Let's recap what we have learned today. Today we learned how to amend last commit. We also learned how to change commit message if we want so. You saw vText editor and learned basics to work in vEditor. Also, we learned how to use step for auto-completion. Now you know how to unstage some changes and how to restore state of the file to the original state since the last commit. That's all for today. Thanks a lot for your attention and see you in the next lesson. Hello colleagues, in this lesson we are going to discuss what remote repositories are and how to work with them. I will tell you what is Git source code hosting and why do we need it. Together we'll review the most popular Git hosting services and we'll compare them. In this lesson we'll create remote repository. I'm going to show you how to push your local repository to the remote. You will run such command as git push today. I will show you what is readme.md file and when you can use it. And at the end of the lesson I will show you how you can clone existing repository to your computer. Let's start. Before we start looking at examples, let's understand first, why do we need remote repositories? Usually we work as a team with other software engineers, and we need to collaborate with them somehow, and we want to have the single place with our latest version of the code. Remote repository will help us with this. Remote repository is the same repository that we already created in this course, but it's just hosted on the internet and available online 24/7. And every developer updates the remote repository on the regular basis. Collaborating with remote repositories means that you know how to push changes there, how to pull changes from there, and how to resolve conflicts in the source code in case you have any. Also, we need to know how to set remote repository. Besides that, in this course we will learn how to manage various remote branches. Each developer still has repository on the local machine, but there is one single place where the code of the latest version should be placed. To start with, let's hold a brief overview what hosting for remote repositories you can use today. On this slide you can see three the most popular hosting for Git repositories. They are GitHub, probably one of the most popular Git hosting in the world. It supports a lot of features that supports and helps you to create efficient continuous integration and continuous deployments processes. Microsoft acquired GitHub repository for huge amount of money. And you know, if Microsoft buys something, that means a lot of product owners, marketers and developers start proactively developing the product to win the competition with other vendors. Bitbucket. It is a great tool made and supported by Atlassian. This tool is mostly liked by developers because of the great integration with other Atlassian's products, like such popular issue tracking system as Jira. It is very convenient to use this tool in conjunction with Jira and knowledge base by Atlassian called Confluence. GitLab. One more popular hosting for Git repositories. And to be honest, it is really hard to compare this one with previous two. More or less all these three source code repositories have similar features. Besides storing of the source code, GitLab offers similar features for issue tracking and project management as GitHub. What we are going to choose? For storing source code for all my students, I use repositories on the GitHub. For storing source code of my own projects, mobile and web apps, which we develop inside my company, we use Bitbucket. Primarily, this is because the fact that long time ago Bitbucket offered possibility to create private repositories free of charge, while this was paid feature in the GitHub. Today you can create either public or private repository on the GitHub for free too. And just to warn you one more time, no matter which online repository we are going to choose, configuration will be the same. So let's start our demo. First of all, we have to create account on the GitHub. The process of account registration is pretty intuitive and easy, that's why I won't focus on that. After you logged in, click on plus sign here. Select new repository, create name of your repository. You can choose a name you would like. For the demo purposes, let it be learn IT Git. We can skip description as of now. I want to make it public to be able to share it with you, team. You can keep your own repository private or public as you wish. We don't need to add neither readme nor gitignore. We'll add this by ourselves. Just press big green button create repository. And here you can find hints what to do next in case we don't have local repository or in case we want to push local repository to this hosting. What is also worth to mention is that you can establish connection with Git via HTTPS protocol or SSH. Establishing connection via SSH protocol requires additional configuration, and I will show you that in the separate lesson. To establish connection via HTTPS, no additional configuration is required. In this lesson I will show you how to push files to the hosting with the help of HTTPS protocol. That's why we need to click here. Okay, what we need to do now? We need to connect our local repository with this remote hosting. How to do this? Here we can see hints. Let's go back to our Git bash in our local repository. First of all, to check that your local repository isn't connected with any remote repository yet, enter the next command, git remote with option V. And we see that our local repository isn't connected with any other remote repository. Okay, then let's perform the next command. Copy this HTTPS URL from here. Press Ctrl and C. Now let's type the following: git remote, add origin, and paste link which we copied. To paste link in Git bash, press mouse right click and select paste option. But what is origin? Origin is a shorthand name for the remote repository. To be more specific, this word is used instead of the repository URL to make referencing much easier. Now we need to connect our local branch master with the master branch in the remote repository. All the time during the development you are going to have two versions of the one branch that you will try to synchronize. For example, if you have master branch in your repository, you should have origin master branch in the remote repository. To connect local master branch with remote master branch, we have to execute the next command: git push origin with option U master. Option U stands for upstream. This option automatically sets the upstream for us, linking our repo to a central one. After this, when we will tell Git to pull changes, it will understand that I want to pull changes exactly from this origin branch. Press enter. It didn't ask me GitHub login and password because they are already stored in my credential manager on my computer. But most likely you will be asked to enter your GitHub login and GitHub password. Follow the hints on the pop-up windows. Now, let's go back to the web browser to explore our original repository. Refresh the page. Congratulations! And you see that you have pushed your changes to the remote Git repository. By the way, can you see the repository description? Usually people use readme.md file to put their repository description. By convention, content of this file is displayed on the home page of the repository. That's why, in case you want to put some description here, just adjust readme file like we did. The one more thing that I want to show you today is how you can clone remote repository. For example, the first day you joined your new job and started work on the new project, you can ask your tech lead where their repository are, and you will be provided with the link. You have to clone remote repository to your machine to be able to work on the source code together with the whole team. How to clone existing repository? Let me show you example. Here is the project with the source code for my Java students. Let me clone it to my local computer so that I could investigate the source code and push changes that I want to. Press here on the green button and select HTTPS for the sake of the example. Copy this URL. Now, on your computer, navigate to any place on your file system you wish. Choose the directory where you would like to store the source code of this project. Open git bash in that directory and execute the next command. Git clone, mouse right click, paste, and press enter button. Now you can check your folder and you will find all files from remote repository cloned here, including the folder of the repository. Here you can find .git folder for this project. Congratulations! Now let's recap what we have learned in this lesson. Today we learned what hosting for Git repositories is, we reviewed the most popular Git hosting. After that we created an account on the GitHub. In this lesson you saw how to check remote repository if needed. Now you can connect your remote repository with the local one and push all necessary changes. Also, you learned how to set upstream for the Git branch. We'll use this knowledge in the next lessons, when we'll create other branches. Now you know why you may need readme.md file in your repository and what you have to write there. In this lesson we reviewed git clone command, and I believe you understand how you can clone repository to your local machine. That's all for this lesson. Thanks a lot for your attention and see you in the next lesson. Hello team, in this lesson I'm going to show you how you can establish SSH connection. We'll talk briefly about why do we need it. After that, I will tell you how you have to generate SSH keys on your computer and where to configure SSH connection in your GitHub account. Also in this lesson I will show you how you can update your remote repository that is connected to your local one. To start with, I'd like you to understand first what is SSH. Because during your life as a software engineer you are going to use this protocol many times to get access to other computers. SSH stands for Secure Socket Shell. It is a security protocol that allows you to connect to a remote computer by using text-based interface. Using SSH you can easily log into another computer from anywhere and perform any commands on that computer or do any changes you wish. The goal of SSH is to make remote connections to computers much more secure. While working with remote repositories, you often have to identify yourself using your username and password. Establishing SSH connection is another way how to identify yourself without using username or password every time. SSH requires both components to be configured. Server side, that is our remote repository, in this case this is a GitHub, and the second part is a client side, that is our local computer. To authenticate user, SSH keys are required. The key come in pairs, public and private key. Public key you can store on any remote server, on the GitHub for example, and the private key stored only on your computer. During the establishing of SSH connection, key pair is checked. In case they are matched, SSH session is established. The cryptography behind SSH key ensures that no one can reverse engineer your private key from the public one. Now you understand that first thing we need to do is to generate SSH keys. Let's do that. There are a few different ways how to generate SSH keys on your computer. And if you Google this question, you may find few commands that help you to generate SSH keys from the console. But I'm going to show you the easiest way to generate SSH keys that almost never mentioned. To generate the key, open Git GUI app. You can find it in Windows Search or just by pressing mouse right click in the File Explorer and selecting Git GUI. If you open Git GUI in the folder where you have local Git repository initialized, it can look like this. But in case you open Git GUI in some other place, it can look like this. Nevertheless, in both cases we need to click on the Help tab here and after that show SSH key. Press Generate Key button. Now I am asked to enter a passphrase. The main goal of this passphrase is to encrypt your private key. In case attacker would steal your private SSH key, it will be useless for him because he doesn't know your passphrase. While attackers spend time on cracking your private key, passphrase can buy you some time to revoke keys and roll over to the new one. By leaving this field empty, we are accepting the risk that attacker can get access to the private key on our computer. I just click OK button. And when I am asked to enter the same passphrase, I just click OK button one more time. And here you are going to see only public key that you can share. Copy this key to the clipboard and open your GitHub account. Here, click on icon of your profile and select Settings. Here find SSH and GPG keys section. Click on it. You can have multiple SSH keys associated with your account. For example, here I have my two laptops connected to the single account, my HP and Asus laptops. To add new SSH key, just click this button. Title can be any title you would like, for example, my laptop. Then put your cursor in key text area and paste the content of your clipboard. I press Ctrl and V. Awesome! Now press Add SSH key. GitHub may ask you to insert password. And I can see the new SSH key is added to this list. Great! What to do next? To work with your remote repositories via SSH protocol, you have to set the proper remote. Let's navigate back to our Git bash to check what remote repository we currently have set. Do you remember the command to check the remote? Git remote with option V. Here you can see that currently we use HTTPS protocol to connect to our remote. We need to change our remote to connect our repository via SSH. Where to find another URL? Let's go back to the web browser to our GitHub account. Here is the repository which we created together on the previous lesson. Let's press this green button here. Do you remember that on previous lesson we selected HTTPS on purpose during the remote setting? Now I want you to press this button, SSH. Copy to the clipboard this URL. Let's get back to the Git bash. On previous lesson you learned that to add remote we have to type git remote add command. But to change the remote URL we have to enter another command. Let's type the following: git remote set URL origin and paste URL that we copied on the GitHub. Press enter. Now let's check our remote. Awesome! Now we see that we are not using HTTPS protocol anymore. Let me show you one more thing so that you will be ready for that. I want to make some changes. Let me make some dummy changes in this file. Now let me add it to the staging area and create a commit. Git commit -a-m test SSH connection. Okay, commit is created. Now let's push our changes to the remote repository. Git push origin master. Origin master is a reference to our remote repository, but on previous lesson we already set upstream for our current branch by using U option. That means my local repository is already aware that this master branch is connected with master branch in origin, and that also means that for me it is not necessarily to write origin master. Let me even remove that now. Press enter. The message which you see here is just to ensure that you trust this remote host and want to connect to it. Type yes to add GitHub to the known host. This message will appear only the first time you connect to the unknown host. And here you see the message that this host is permanently added to the list of known hosts. The list of known hosts is located in .ssh folder. You can find this folder inside your computer user folder. In Linux-based systems, including Mac OS, this folder is located in the home directory. Here in the directory you can find private and public SSH key and file with list of known hosts. You can open this file in the notepad if you want to explore its contents. Let me search for GitHub mentions in this file. And here you can see, GitHub was added at the end of the list. And let's check our repository to make sure that our commit was successfully pushed to the remote. I refresh page, and here I already can see my last commit message. And also I can check commit history. Click here on commits. Here's our latest commit. Great! Now let's recap what we have learned today. Today we learned what is SSH protocol and when we need to use it. You understand how SSH connection is created and how to generate SSH keys. We configured our remote repository to work through the SSH. And we learned what unknown hosts are and how to add GitHub to the known host. That's all for now. Thanks a lot for your attention and see you in the next lesson. Hello dear students, today we are going to have a very important lesson. Today we'll learn what branches are and how to ensure smooth navigation between them. I will explain you how commits are stored in Git in a nutshell. we'll answer the question what actually a branch is. I will explain you today what is a Git head. After you will understand the theory, we will proceed with practice exercises to learn commands that will allow us to create new branches and navigate between already existing ones. You will learn such commands as git checkout and git switch. We'll learn git branch command, and I'll tell you how you can list all your local branches and remote ones. During the practice exercises, I will show you how you can remove branch locally and in remote repository. While navigating between the snapshots, I will show you what detached head state is. Besides that, today I will show you basic Linux terminal commands for navigation in the file system, creating files and listing files. Let's start. And to start with, let's imagine the case that you receive a task on your work and you need to implement it. To start work on the new task, you have to isolate your changes from the stable version of your code to make sure you will not mess it up. To isolate our code during the development of the new feature, Git allows us to create separate branch. What is the branch? We briefly discussed what is the branch when we talked about our master branch, but let's recap one more time. In simple words, you need branch to diverge from the main branch to continue development without messing with the main development branch. For example, here's the main development branch where the latest version of the code is stored, and you want to start work on the new task. You create separate branch. You create commits on that branch, and after that you merge your branch with the development branch. Easy. Meanwhile, another developer can create a new branch and work in parallel with you for some period of time, and merge his changes with yours later. That's why we need branches during the software development in a team. To understand how branches work, we need to understand a bit deeper how Git stores information. You remember that Git stores files as a series of the snapshots. When we create a commit, Git stores a commit object that contains a pointer to the snapshot of the content that we added to the staging area. Also, this object stores pointers to the commits that directly came before the current commit. Before we start learning specific commands how to create branches, I want you to understand the theory, at least on the high level, how Git works. What actually happens when we create a new branch? On this slide you can see that I created a new branch with the name testing. What actually happened in the language of Git? I just created a new pointer on the current commit. On the moment when I created a new branch from the master, two pointers are pointing out to the same commit. But how Git knows that at this specific moment of time I am on the master branch, but not on the testing branch? There is one more pointer called head. Now let's imagine we switched branches. I'll show you commands a bit later in this lesson when we will have practice exercise. Right now, I want you to focus on the theory and this visualization. Switch branches in the language of Git is to change head pointer. Now head is pointing out to the testing pointer. Being on this branch, we can create a new commit. What happens next? Our testing branch moved forward while master branch still points to the previous commit. So in this particular case, if you would switch back to the master branch, you would see the state of the file system which was before your last commit. Okay, now you can imagine how pointers in Git works, but let's move further. Now imagine that somebody, some other developer, managed to put changes into the master branch, and new commit in master branch appeared. Your project history has diverged. Both changes in these two commits are isolated from each other, but we can merge these changes if we want. That is the exact scenario which we need to learn together. In this course we are going to learn how to merge changes together from different branches. So, right now you already understand the theory of branches. You can visualize in your mind how navigation between branches works and why do we need this. Now it is time to learn specific Git commands that will allow you to navigate between branches. Let's practice. Usually on your job you are going to use some task management system or issue tracker that will give you unique ID of your task. Imagine that we have task to implement logic of discount calculation for our customers based on their history of purchases. Where we need to start? We need to start from creation of the branch. There are different ways to create branches. One of the options is to use the next command: git branch TA301. Let's press enter. New branch is created. But you see here in parentheses, I am still in the master branch. To check which branches I have locally, I have to just use the next command: git branch. To see all remote branches, I have to use the next command, git branch with option R. And you see that right now I have only one branch in remote, that is my origin master branch. To see all local and remote branches, you have to use the A option, git branch -A. And here we can find all local and remote branches. But to be honest, the branch command is rarely used among developers to create a new branch, because this command only creates branch but not get you to the new branch. Usually software engineers use the command that creates and changed branches simultaneously. So let's type the following, git checkout. Checkout command is for changing branches. Option B. This option is to indicate that I want to change and create new branch. B stands for branch. And now let's specify the name of the branch. Task 301 underscore discount underscore calculation. Usually with the task ID, we would like to specify a brief description of what changes will be in this branch. Press enter. And we switch to the new branch. And in parentheses, you can easily identify on which branch you are right now and where is your git head pointer. Okay, we created changes. Now let's implement our task. For the sake of example, I won't write any code and I will not implement any logic related to the discount calculation, because I want you now to focus only on Git. But let's imitate that we did some changes and all of them stored in the new file. Let me use Linux commands to create a new file. First of all, I want to navigate to the folder with the source code, cd src, and press enter. cd stands for change directory, and you see here in the path that I navigated to the src directory. Touch discount calculation service.java. Touch command allows us to create file. This is one of the possible ways to create files with Linux terminals. To check what files you have in the directory, let me show you one more Linux command. ls with option L. ls is a command that lists files in the specific directories. I don't see a lot of sense in reviewing all possible options for ls command, because most likely you won't use them all. I use option L to have such formatting. I will leave the link in attachments to this lesson about ls command, and if you wish you can try different other options. And we see that new file is created. Here it is. Let's also check that file was created in the File Explorer. And we can also find it here. Awesome! We have just created a file and here it is in the src directory. Before we proceed, I want to show you one more interesting command for navigation in file system via terminal. cd ... Double dot always references to the parent directory. So, in case you want to navigate one level up, you have to use this command. And you see, we're already in our root project directory and not in src folder anymore. Now let's pretend that our work on this task is completed and we did everything what is needed in scope of this task. We have to create a commit with our changes. We add file to the staging area as usual. Git add dot. Now we create commit. Git commit -m personal discount for user can be calculated. Great, we have our commit in our branch. Let's check git log. Git log -2 to see only last two commits. We can see here that this commit is from master branch, and here is our new commit on our new branch. By the way, just to remind you that git log shows you the history of the current branch only. To watch all commits across the repository, you have to type git log with option all like this. Git log _all. To watch the history of commits for the one single branch, type git log command with the branch name like this. Git log TA00, and do not forget to use tab key for autocompletion. Okay, this information might help you in the future and just for the reference. Let's move on. I can easily navigate between branches in my local repository. We already learned the command that allows us to switch branches. Now let's switch back to the master branch. Git checkout master. I don't have to use B option because master branch already exists and I don't need to create a new one. And we can see that name of the branch is changed here in the parentheses. Let's check now the file list in the src folder. Let's navigate to src folder first. cd src. And now let's use another command to list files. ls-l. Wow, magic happened. Where my discount calculation Java file? It is in another snapshot. If you don't believe that file is disappeared, let me show you in the file explorer. Can you see this? The file is disappeared. Now you learned how to navigate between branches. Can you navigate only between branches? Or no? You can also navigate to the specific commit. How to do that? Let me show you. At the beginning, let's find the commit where I want to switch. Git log-3. Okay, let me switch to this commit. Git checkout 06d1b and press enter. So, you need to enter a unique combination of characters so that Git would understand where you are referencing to. And now, we switch to the state of this particular commit. Right after you switch to the specific commit, you see warning message that you are in detached head state. What does that mean? That means we are not on the specific branch, because most likely this commit is present in different branches. Even if you would create commit bin here, nobody would be able to find this commit other than via direct checksum identifier, because new commits won't be connected with any specific branch. That means these changes can easily get lost once you check out a different revision or branch. So, why then we need to check out to a specific commit? During your life as a software engineer, you might want to navigate to the specific commit to investigate how some specific chunk of code worked in the past. For example, in case you troubleshoot some defect, you want to investigate how the code worked before, and you want to execute this code and debug it. That's why you might want to navigate to the specific commit. What I want you to remember is that you shouldn't do any commits in this state. Just investigating and experimenting is fine, while being in the detached head state. Doing the commits in this state is not the best idea. Let's get back to our task branch. Git checkout TA0001 and press tab 2 times for auto-completion. You have to press tab 2 times because we have TA301 branch and TA301 discount calculation branch. And tab allows you to select the exact branch you need for auto-completion. Now let's push it to a region. Git push a region with option U, TA301 underscore and tab key to autocomplete. Nice. Branch was pushed to remote. New branch in remote has been created, and branch remote tracking has been configured. Let's check the branch in the remote repository. Let's open src directory. And here you can switch branches. And we can see that on our new branch we have new file. Click on Insights tab. Select Network. Here you can see commits history and see that our new branch is one commit ahead of master branch. Okay, we learned how to create branches, but at the beginning of the lesson we also created one branch. Let me list all branches in Git bash one more time. Git branch with option A. This task branch I want to remove. How to remove branch? Git branch with option D, D stands for delete, and branch name. We can find message that branch has been deleted. And for the sake of example, let's pretend that I want to remove discount calculation branch from the remote too. How to do that? Git push a region with option delete and specify the branch name here. Press enter. Let me open my remote repository one more time. And when I try to switch branch, you see that I can't find my new branch here anymore. Now you know how to remove branch locally and in remote. But for our next lessons, let me push our branch to a region one more time. Because already in the next lesson we are going to learn how to create pull requests and how to merge branches together. Git push a region with option U for discount calculation branch. The last but not the least thing that I'd like to mention today is that starting from the Git version 2.23 onwards, instead of git checkout command, new command is also available to use. Git switch master. In case you want to switch to the new branch, you have to use C option like this. Git switch option C new branch. Here C option stands for create. To navigate back to the previous branch, type the following: git switch and hyphen. And I navigated back to the master branch. To be honest, I didn't saw engineers who already actively use switch command, because it is a big habit to use checkout command for branch navigation in the community of engineers. Introducing git switch command wasn't done to confuse developers even more. The thing is that checkout command sometimes might be used to reverse modifications. So, to clearly separate commands, new command with single go to switch branches, git switch, was introduced. That's it. I believe right now you know about branch navigation even more than some senior engineers. And right now, let's recap what we have learned today. In this lesson you learned what a branch is. You understand how mechanism of Git branching works. We learned what is head pointer in Git. After we learned theory, I showed you few ways how to create new branch in Git. We did a commit with our changes on the new branch. We understood how we can navigate between branches and what detach head state is. Also, in this lesson, we learned how to remove branches and how to use git switch command to navigate between them. During the lesson, you learned basic Linux commands that allows to navigate in file system, create files and list files in the directory. Thanks a lot for your attention and see you in the next lesson. Hello dear students, today we will learn with you what a pull request is and how to create one. After we will understand the definition of PR, I will show you how you can create your first pull request. We'll learn what is the difference between pull request and merge request. In this lesson we are going to learn how we can merge commits from different branches. We'll learn the difference between different merging strategies. I will show you how to add collaborators to your repository. You will add me as a collaborator so that I would be able to evaluate your code. First of all, let's understand what is a pull request. Pull request is a method of submitting contributions to a project. Imagine that you worked few days on implementing logic of discount calculation for your users and finally you completed your work. Now you need to merge your code with the latest version of the source code. Literally, you have to merge commits of yours with commits that were done by other developers. Why this method is called a pull request? You can pull changes from one branch to update another branch. And by submitting a pull request, you ask other people to review your changes and pull them into another branch. Does it make sense now? Now words pull request make more sense. And by the way, pull request, that is terminology of the GitHub and Bitbucket repositories. GitLab uses another term to describe the same process, merge request. The idea is pretty similar. We may want to merge two branches, and merge request means that you want to ask somebody to merge your changes with the other branch. Both pull requests and merge requests use git pull and git merge commands. We are going to learn these commands in the next lessons. But don't confuse this terminology. PR and MR refers to a much broader topic, and I believe you understand that both of these terms describe the same process. Now when you understood that, let's proceed with our demo. On the previous lesson, we merged our branch to the remote repository. We had new file added, discount calculation service. Let's also change existing file for the sake of the demo. Let me add spaces here in the hello world file. And I save this file. Now I will add changes to the staging area and will make a commit that spaces were added to the hello world file. After I created the commit, I push it to the remote branch. To create a pull request, you have to have two branches. And right now, we have master branch and our task branch. Nice. There are a lot of different ways to create a pull request. Let me show you one of them. Click on pull request tab here. Now click on the new pull request button. And here you have to specify which branch you want to pull into which branch. In our case, master is a main development branch. Depending on the branching strategy that you are going to have at your work, you might have development branch as a main development branch, and master branch will be used only for releases. In our particular case, we want to merge task 1 branch into master, That's why here I selected task 1 and here I have master branch. Here you will see the difference between the state of these two branches. Let's create a pull request. Additionally, you may specify pull request description. Here on the right, you can specify pull request reviewer and pull request assignee. What is the difference? Reviewer is someone you want to review the code, and this can be the person who is not necessarily responsible for merging branches. Probably colleagues of yours or software engineers from another development team, but who needs to be aware of changes in your project. On the other hand, assignee is someone who is responsible for merging this code. This can be a tech lead on your project or owner of the repository who is in charge of merging code to the master branch. Later today I will show you how you can add me as an assignee. Right now just click Create Pull Request button and pull request is created. On this tab you can see what commits you have on your branch. On this tab you can see what files were changed in comparison with the branch where you want to merge your changes. We can see that there are two changes. New file is created and the spaces are added to the Hello World file. Assignee and reviewers will go over all your changes to investigate what exactly is changed in your pull request. Reviewers can leave comments here under specific lines of code. For example, why so many spaces here? And the discussions have to be resolved. All my students who works with me offline assigned me to their pull requests, and during the offline lessons we review the pull request together and discuss with the group what can be improved. Let me also teach you how to add me to your pull requests as an assignee. I don't guarantee that I will be able to check each your pull request, because for your homework verification I use special type of tasks, coding exercises that verifies your homework automatically. But you can learn at least how to add me here as an assignee. Click this settings button. Next click Manage Access. You might be asked to enter your password. And I believe you understood that this is project specific settings. So, in case you want to add collaborators to your another project, you should open settings of that exact repository. Let's add me as a collaborator to your repository. Press this green button, invite a collaborator. You can find me using my nickname, Andrei Petaha. I can't find myself because this is against the rules and this doesn't make sense. But I can find one of my friends. For example, let me find friend of mine with the nickname Svetobatko. Similarly, you have to find my picture. Click on it and press green button. That's the rule of the GitHub. Always press the green button. Just joking. I will not add Andrei because I don't want to spam him. Because after I press green button, Andrei should receive request to become a collaborator in my repository. And he also has to approve this request, and only after he approved the request, only after that you will be able to find him in assignee dropdown for your pull request. To navigate back to your opened pull request, you can open Pull Requests tab, and here's our fresh PR. I can press GR icon and assign this pull request to myself. Okay, let's proceed. As I mentioned, reviewers and assignee check your PR, and once all discussions are resolved, assignee merges pull request by pressing this button. This merge button has three methods. They are create a merge commit, squash and merge, rebase and merge. Keeping a clean Git repository is one of the top priority tasks for all contributors. The clean Git tree can save you a lot of time when trying to track down commits related to a bug or issue. The default option, which is create a merge commit, will take all commits from the PR and add them to the master branch with a new commit. Let's take a look at this slide. Imagine that there is a main branch. We have init commit and commits 1 and 2. You created your feature branch. On that branch we created commits 3 and 4. You prepared pull request. And now we select default option for merging commits. And you see that new commit will be created on the master branch. The commit message will look like this: merge some specific branch. That's it. The result message is not very helpful when you will try to understand what this commit is about. That's why this is not a recommended option by many developers. We want to keep our Git history clean. Imagine the same case, but this time we would select the second possible option, which is squash and merge. What is going to happen in this case? Commits 3 and 4 won't be added to the master branch. What will happen instead? Commits will be combined and any other commit message can be added. Commit 4 will be squashed into commit 3 and we will give any message we would like with the help of GitHub interface. And what will happen in case I will opt for the third option, rebase and merge? During the rebasing, our commits are put on top of the master branch, like you see on this slide. Commits 3 and 4 are just put on the top of the master branch. Definitely, your tech lead will choose strategies that you have to follow, but my personal preference is rebase and merge. Why is not squash and merge? I believe if developer wants to squash commits, he or she has to do that locally in the local repository before even pushing branch to the remote repository, but not ask assignee to squash your commits. But I also met tech leads that would prefer squash and merge rather than teach engineers how to write commit messages and how to do squash. Later in this course I will show you how you can squash commits. Being a project owner, you can disable merge methods that you don't like. To do that, click on the settings button and scroll page to the bottom. Find merge button and uncheck methods that you don't need. And if I would open my PR one more time, I can see that I have only one option available. Let me select the third method and close my pull request. Awesome! Now you can delete the task branch, because it is not needed anymore in remote repository since you have already merged it into the master branch. And to not confuse anyone, let's remove it. You can see that there is no task branch anymore in our remote repository. Now our pull request is closed, and we can check our commit history of the master branch. Make sure you are on the master branch, and click here on commits. And we see that no other commits for merging were created, only commits that were created by us. Great! I believe now we can recap everything what we have learned today. In this lesson we learned what a pull request is and what is the difference between a pull request and a merge request. Together we created a pull request. I showed you how you can add collaborators to the repository, and we discussed what is the difference between assignee and reviewer in pull request. Also, today we learned different merging strategies and understood the difference between them. That's all for now. Thanks a lot for your attention and see you in the next lesson. Hello dear students, in this lesson I will teach you how you can update your local repository. Today I will explain you why we need to update our local repository, how often we have to do that, and what commands we have to use. Today I prepared special demo with the end-to-end flow in which I will show you commands that you are going to use in most cases at your work. I will tell you today more about git fetch, git merge, git pull commands. Also I will explain you what does fast forward mean. We are going to learn a lot today. Let's start. First of all, let's answer the question, why we have to update our local repository? We have to update our local repository because we want to be sure that the code that we created will work with other code as expected. That is the most important reason of updating local repository as often as we can. To avoid situations when you work on some task for 1 week or 2 weeks and when you need to merge your code with master branch, you discover multiple conflicts in your code. Today I will show you commands and real examples how you can update your local repository. In previous lesson you learned how to prepare pull request and merge changes. Now, let's imagine that you successfully completed your previous task, and you are about to start your work on the new task. Right now, in my local repository, I am on the task branch. We already know that to start work on the new task and to separate code one from another, I have to create a new branch. Usually, I want to create a new branch from the latest version of the source code, so let me switch the master branch. Okay, I'm on the master branch, but do I have the latest version of my code here? Let me navigate to the src folder and check whether I have all latest updates on this branch. To navigate to the src folder, I have to type cd src. Okay, now let's list all the files. ls-l. And you see that we don't have discount calculation service here. Why? I am on the master branch, and we merged our changes with the master branch in the previous lesson. Let's not confuse two things: master branch and origin master branch. In previous lesson, when we merged pull request, we merged code to the origin master branch, but we didn't merge code into our master branch. So what to do now? Now we are going to learn few commands. Git fetch. What is git fetch command? This command fetches all changes from the remote repository and put it in your local repository. One more time, important thing to mention here is that changes are not merged to your local branches. So, in case some commits in origin master branch exist, which your local repository is not aware of, fetch command will save information about these changes in your local repository. Let me press enter now. Based on the log messages here, we can conclude that some changes were downloaded from the remote. Okay, probably now I have all latest changes in my branch, including new file discount calculation service and all latest changes from the hello world file. Let me check it one more time. ls-l, and again, I don't have any latest updates. Why? Because I have just downloaded information about these changes, but I didn't actually merge these changes in the local branch. Then what is the purpose of this command at all? Imagine that you are working on the new changes, and you don't want to merge latest code into your branch to not break anything. And you would like to know whether there are any changes in remote branch that are needed to be merged. One more use case of using git fetch command. You can fetch changes while sitting in the office under secured VPN connection, and you can merge carefully your code later when you want, while sitting on your cozy chair at your home. But what if I'm already at my home sitting on the cozy couch? What I have to do now? Now I have to merge these changes into my local branch. So I'm doing git merge command. Git merge. Awesome! It looks like some changes have been merged with my master branch. I see fast forward message here. What does that mean? A fast forward is what Git does when you merge or rebase against a branch that is simply ahead the one you have checked out. That means there was no diverged branches, and that is the new value of the branch is a direct descendant of the prior values. So, we add origin master branch that contains commits that are descendant of our previous master branch. That's why we call such merging as fast forward. Now, when we have merged latest updates, let me check list of files. ls-l command. Wow, finally I have discount calculation service file in my file system. That is the latest changes that we merged in the remote repository. Let me also check that updates from hello world file is also in place. In previous lesson we have updated hello world file and put extra lines in it. Let me open this file in nano text editor. nano hello world.java. Nice, I see all new line characters are in place here. Let me exit nano editor by pressing Ctrl and X simultaneously as it described here. Now I want you to learn one more command. That is git pull. What is git pull command? Essentially, git pull is a combination of two actions, fetch and merge. So, in case you want to fetch all changes from the remote repository and at the same time merge them into the branch, you have to use git pull command. During our demo today, I want to show you real-life scenarios that will happen with you on your workplace. I want you not to learn just commands, but understand how you will use Git while working with team. To demo this, I prepared end-to-end flow that will show you the full scenario of what we learned so far. And I want you to be ready. I want you to understand how team development is happening. Together, we are going to imitate the next scenario. Imagine that we work on implementation of virtual card in our online shop. We are working on this task. At the same time, developer number 2 works on the implementation of service that will provide functionality of stock management. Both engineers created branch from the same revision, from the same commit. After that, we created pull request and our changes were successfully merged. And after that, developer number 2 created pull request and his pull request was successfully merged. After that, we want to proceed with implementation of the next task, product reservation, let's say. But before start work on the new task, we have to pull all the latest changes to create the branch with the latest updates. And we have to execute git pull command. Hope you are not confused. but I want you to be prepared for the real life, and this is the easiest real life scenario with only 2 developers. Let's then together try to reproduce this scenario. So, we are going to have next steps. Developer 1 and 2 created branches and commit their changes. After that, both engineers created PRs that were merged to the origin master branch. Developer 1 pulls latest changes to start work on the new task. Let's start. Here is what we are going to do on our work. Let's check latest status of the master branch. So, it is up to date with origin master branch. Cool. Now let me create new branch. Git switch with option C TA302 virtual card. We switch to the new branch. Let's imitate implementation of this task. I will create special directory called card. mkdir card. mkdir is a command that creates a directory. Now let's navigate into this directory. cd card. Now let's create card management service file and we will pretend that there is a task implemented in this file. Touch card management service.java. By the way, you can't push and commit only folders. If you want to set some basic folder structure for your program, there should be files in these folders. Okay, now let's add this to the staging git add dot and commit this change. Git commit -m card management is implemented. Okay, we have a commit now. Let's push it to origin. Git push -u origin TA302 virtual card. We'll create a pull request now. Give me a few seconds here. You already know how to create a PR from the previous lesson. PR is created, but we won't merge this code so far. Meanwhile, developer number 2 created separate branch to implement stock management. Okay, the same as here, developer number 2 on the master branch and in the src directory. He wants to start work on the new task and creates new branch. Git switch with option C TA303 stock management. Let's create new folder in the src directory. mkdir stock. Right now, I created directory in the src folder. Let me navigate there. cd stock. Okay, I'm here. Now let me create a file. Touch stock management service.java. Cool. Let's add this file to the staging area. Git add dot. And now let's commit. Git commit -m stock management is implemented. And let's push it to the remote. Git push -u origin TA303 stock management. Now I have to create pull request for this change. Let us merge 2 pull requests now. And you see that code in master is updated. In case during the new task implementation you would need either card management service or stock management service, it is better for you to learn it earlier. Because first of all, probably you are going to use this code. Or this code might break your code. Anyway, it is better to have all changes from all developers on place in your local repository before start any new work. And finally, we return to the main branch and want to start work on the new task. But right now we have to make sure that we have the latest changes in the master branch before creating new branch. Okay, what we have to do now? Probably you would say git fetch and git merge, but let's execute git pull command. Awesome! We pulled our changes and we are ready to work on the new task. You see here I pulled card management service and stock management service, and you see that we don't necessarily have to do git fetch and after that git merge command. Git combines these 2 commands into one. I can check my cart and stock directory and find files there. You see? We finished our practice exercise. Hope this small demo will help you to understand how we can use Git during the team collaboration and new task implementation. Let's recap what we have learned today. Today we learned why we need to update our local repository. We also learned git fetch, git merge and git pull command. Now you know that you have to update your master branch before start working on each new task. You also understand the difference between git fetch, merge and pull commands. Today you saw what is fast forward in Git. And at the end of the lesson I showed you end-to-end flow of how team development is look like with the help of the Git. Thanks a lot for your attention. See you in the next lesson. Hello dear students, in this lesson you will learn what merge conflicts are. In simple words I will explain you when merge conflicts could appear. Together we'll reproduce real-life scenario with merge conflict. And what is even more interesting, I will tell you how to solve merge conflicts. Together, during the demo, we are going to solve merge conflicts that will appear during the pulling from the remote repository. And as usual, let's together give a definition to the merge conflict term. The merge conflict is a specific event that takes place when Git is unable to resolve differences in code between two commits automatically. This is an event which we can't avoid during the development in the team. Usually it may happen when two developers change in the same line of code. How it can be? For example, imagine that in our project we have some web page, and developer number 1 worked on the task to implement login button and added some styles. He included these styles into our HTML page, and developer number 2 worked on the task for implementing carousel on the home page. Engineer number 2 also had to do adjustments in the home.html page because he wanted to include his custom styles and adjust page markup a bit. First engineer pushed his code to his origin branch. He also created a pull request that was successfully merged. But when second engineer tried to create a pull request, he received an error that there are merge conflicts. Why? Because two engineers updated the same file, home.html, and most likely in the same lines of code. And Git can't understand what version of code is the latest one and the proper one. Git can't merge this code automatically. This situation is called merge conflict. What to do in this case? In this case, conflict should be resolved manually. Engineer number 2 has to pull all latest changes into his branch, investigate where exactly merge conflict is appeared, and resolve it. By saying resolve it, I mean change source code and create a commit that will be approved to the Git that these changes are created intentionally and were reviewed by some engineer. After merge conflict is resolved, the file can be merged to the master branch. So, today we are going to review the example how this merge conflict is created and how to solve it. Let's start. To start with, I'd like to inform you that for the sake of the demo, before this lesson, I created this home.html file in the web content directory. Let's take a look at it. As you can see, this is the simplest possible HTML file with hello world text in it. Nothing special, to not lose focus from the goal of our lesson. This file was created in the separate branch and merged to the remote repository. You already know how to do that. Now, imagine that developer 1 wanted to create styles for login button and pop up on the home page. Let's create a new branch for that. Git switch with option C, TA304 login styling. Just for the sake of example, let's imagine that we have some styles folder where all CSS files should be stored. For those who are not aware, files with the CSS extension are used for styling your elements on the HTML pages. CSS stands for Cascading Style Sheets. Okay, let me create styles folder in my src directory. mkdir styles. Now let's imagine that during the task implementation, developer number 1 created new CSS file with description of custom styles. Touch styles/login.css. Also, engineer number 1 adjusted home.html file to include this CSS style there. To reproduce the steps that I did in this lesson, you can use any text or code editor you would like. For the sake of the demo, I will use Nano text editor to save time on switching between different screens. Let me open home HTML file to adjust it. Nano, web content, /home.html. Just to remind you, I always use tab key for auto-completion in terminal. According to rules, I can include CSS style on this page like this. In the head tag, I should put my link tag with the path to the CSS file. Head, link, rel, style sheet, href, /styles/login.css and close the link tag. And head tag is closed. This is not HTML CSS course, that's why I won't stop on the things I wrote. But I would like to draw your attention to the lines which we changed. We changed lines 3, 4 and 5. Remember this. This is important for understanding of the merge conflict topic. I exit this file and save it. Now I add everything to the staging area, create and commit and push it to the origin branch. Those are the things that we have already learned in the previous lessons. Give me a few seconds here. Git add dot, git commit -m login pop-up during login, git push with option u origin TA304 login styling. Also, I can create pull request, but important thing right now is not to merge your pull request. Why? We need to imitate case when developer number 2 started implementation of his task without knowing about changes in the home HTML. Understand? Right now let's pretend that we are the other engineer. Let me navigate back to the master branch and create new branch for my task from it. Git switch master. Git switch with option C TA305 home carousel. Nice. Now I have to create my own styles for carousel. Let me create file in styles directory. Taking into account we switched branch, I don't have styles directory here. Let me show you this. ls with option L. And you can see that styles directory is not created yet on this branch. Let me quickly create it. mkdir styles. Now I can create my CSS file. Touch styles/carousel.css. And now let me adjust home HTML file. Nano web content /home.html. I will put reference to my CSS file here. Head, link rel style sheet, href /styles/carousel.css and close the link tag. Head tag is also closed. And you can notice that I changed lines number 3, 4 and 5. The same lines that other developer changed. This is important. Let me close and save this file. I am going to add all changes to the staging area, commit them and push to the remote repository. Give me a few seconds here. Git add dot, git commit with option M, carousel on the home page, git push with option U origin TA305 home carousel. Now, imagine that during implementation of the home carousel task, pull request for login styling was merged by a tech lead. Let me merge it. Okay, it is merged and nothing bad happened. Now let me create a pull request for carousel implementation. First of all, I see here a warning that this branch can't be automatically merged, but still I can create a pull request. And after I created a pull request, I see that my merge button is disabled because of the conflicts. You can see hint here that you can solve conflicts in the web editor. While this can be an option in case of the resolving of the small conflict, this is not an option for the most cases. Why? Because of the few reasons. Reason number 1. Most likely you have more complicated conflicts than we have now here, and this is not convenient to change it in web editor. Reason number 2. After resolving conflicts you want to be sure that you didn't break anything. For this, you have to have your code on your local machine to run unit tests or integration tests, or in case the HTML editing to open HTML page to make sure that everything is okay with your markup. So, I will show you how you can solve conflicts on your local machine. Let me get back to the Git bash. I am on my task home carousel branch, as you can see here. To resolve the conflicts, I have to merge origin master branch into the current branch. You already know that merge command merges different branches, but let me show you how you can merge remote branch into the current one. Git pull origin master. You also learned in previous lessons that pull command merges changes into the branch. And here you can see the message that there is a conflict in this file. Automatic merge is failed. Let me resolve conflicts. I have to open in any code editor file where I have conflicts. For the sake of the demo, I will use nano editor in this lesson. Nano web content /home.html. And here you can find different symbols that Git added to our file. That is how Git shows the conflicts. You already know that head is a pointer to the place where you are currently in your working directory. So here you can see our version of code. We want to insert carousel CSS. And here changes from the master branch that were merged after implementation of task by developer number 1 and checksum of that commit. We have to manually adjust file. After some analysis, I understood that in this particular case I want to keep my changes and changes of developer number 1. We see that lines 3 and 5 were the same in two versions of code, but only line number 4 was different. We used different CSS file names here. Let me adjust markup accordingly. After I am done with changes, I exit and save this file. Here in parentheses, you see mentioned that I am in process of merging two branches. Also, you can see that Git suggested me to create a commit once conflicts are resolved. Let's follow this advice and create a commit. If we would check status with git status command, then we would see that new file login CSS is already added to the staging area. That's the one from the master branch where we don't have any conflicts. And here's the file where we had a conflict. Let me add it to the staging area. Git add dot. Now let's check status. And we can see that all files are in the staging area now. Let's create a commit. Git commit. I will skip adding message now because for such cases Git already storing message for me. The message that states that master branch is merged into the task branch. Let's close this text editor. And we can see that we successfully merged changes. Now we need to update our branch in remote repository. Let's push our changes. Git push. Now let me refresh page with my pull request. I can't rebase and merge, and I will explain you why in the next lesson. But I can merge with creating a new commit. I believe you remember that in previous lesson I showed you different merging strategies and how to allow different merging strategies here in the settings under merge button section. Congratulations! You resolved your first merge conflict. But unfortunately, we are not following right now best practices of keeping Git history clean. Why? Because first of all, we created separate commit during the merging origin master branch with our task branch. And right now, we are under the risk to create one more commit for merging branches. Can you imagine how our Git history tree will look like after all of this? Your tech lead will be disappointed. Just joking. In the next lessons I will show you how to avoid this and how to keep your tech lead happy. But still, to understand the next lessons you had to understand this lesson and why pulling origin master into your branch to resolve conflicts is not the best approach. While this approach is still valid in some companies and in some development teams, that is not the approach which I would approve in my development team and in my company. Probably you're already aware that I am CEO of my own software development company, and when I interviewed engineers, I paid extra attention to their experience of working with Git. Because during the development of complex projects in cross-functional teams, these skills are very important. I'm going to create top-notch software engineers from you during this course. That's why we'll learn other ways to solve merge conflicts. Okay, I believe we are good for today. Let's recap what we have learned today. In this lesson you learned what merge conflicts are. Moreover, together we even reproduced merge conflict on real-life example. You learned how to resolve merge conflicts locally and how to merge origin master branch into your task branch. Thanks a lot for your attention. See you in the next lesson. Hello dear students, in this lesson we'll learn what a Git rebasing is and what force update is. I will show you how and when you can apply git rebase command. I will explain you what rebase actually means. Also, I will explain you the difference between git merge and git rebase. After we will understand theory, we will take a look at real example and we'll learn how we can use rebase command on daily basis. You are going to see how to keep your Git tree clean. During the lesson, you are going to learn how to solve conflicts that could appear during the rebasing on the other branch. On real examples, I will show you what git rebase with option continue means and how to complete rebasing process. After we changed local commit history, I will show you what force update is and how force with lease option may help us. And at the end of the lesson, I am going to share with you 4 rules of happy work with Git by Andrei Pataha. Just joking as always. And to start with, let's discuss the problem which we faced during the previous lesson. If we resolved conflicts with pull command, you saw that one more commit was created. And you also saw that I can't merge with rebase strategy to master, I can only merge with new commit. So, our problem is how to keep Git history tree clean. To proceed showing you new commands, let's understand first what rebase is and how it works. In general, there are 2 main ways to integrate changes from one branch into another. They are git merge and git rebase. We already learned in previous lessons more about git merging branches. Now let's understand on the high level what is a rebase. Let's recall an example when we had diverged branches. The easiest way to synchronize 2 branches is to merge them. So, to merge C3 and C4 snapshots we have to create one more snapshot, thus one more commit, C5. This option works just fine and we saw how it works. But do we have another option that will not create additional senseless commit? Yes, we do. Rebasing on the other branch. What does that mean? We can take changes that we have in C4 commit and put them on top of C3. That means you can take changes that were done on one branch and apply those changes on the other branch. In our example, I can execute command git rebase master while being on the experiment branch. This will lead us to the git history that you can see on this slide. You can see that C4 snapshot is going right after C3. This will allow to create pull request and merge branches in GitHub with rebasing strategy. In this particular scenario, we can switch back to the master branch and do fast forward merge, like it is shown on the slide. And in this case, you can see that there are no any other commits for merging branches, and we have clean git history. We're also going to have lesson about interactive rebase a bit later in this course, where I will show you how you can use rebase command to combine commits or to change commit messages. But in this lesson we'll learn rebase command only from the point of merging changes from different branches. On the previous slide you saw git rebase command to rebase changes from another branch. But in real life example later today we are going to use a bit another variation of this command, git pull with rebase option. So what is the difference between git rebase and pull with rebase option? Git rebase command rebases the branch which we want. Git pull with rebase option can be treated as shorthand for git fetch and then git rebase command. You will be able to fetch all latest changes from the remote repository prior to rebasing our code on top of it. Because if I would just use git rebase master command, Git would only take into account what local repository is already aware of, but not the changes from the remote repository. This is very important practical tip. That's why this video course is so valuable to all my students, because even if you would read documentation and use git rebase, you wouldn't reach the expected goal. And it is not clear that pull command has rebase option, if only you read all git documentation. Probably by this very moment of our lesson you are wondering, what is better, git merge or git rebase? Which one should I use? To give you the full answer, I'd like you to understand one more time what repository's history means from different point of views. Repository history is the record of what actually happened. From this point of view, it might seem like not a good idea to change git history. From this angle, using rebase is similar to lying about what actually happened in your repository. But is this valid comment all the times? Or there are some exceptions? What if there are a series of merge commits that brings us almost zero information about code version improvements? That brings us information that branches were merged. Okay, and what? That is logically that branches should be merged at some point. but I'm more interested in the functionality of the specific version of code rather than the fact that there was code merge. That is the other point of view on what repositories history means. My personal opinion is that we should treat our Git history as a story of how our project was made. If we are writing a story, there is no harm in doing side notes and tracking each step. But when times come to release the story and show it to the world, I want to tell more coherent story without all my drafts and dead-end paths. But despite my personal opinion, I believe you understood that there is no right answer which approach is better. And just keep in mind that all projects are different and there is no silver bullet for each project. There is no one-size-fits-all approach, but being a true professional, you have to be aware about different points of view. That's why I believe it is important for me to share this with you. Okay, now when you understood the theory of Git rebasing, I suggest looking at our practical example. Team, to understand the demo in this lesson, you have to understand the demo from previous lesson, because we have the same context as in previous lesson. We'll proceed from the point where we finished previous time. Let me call git log command of last 3 commits. Git log -3. Here you can see that I have merge commit. When we resolve together merge conflict, you can see here that this merge commit of this and this commits. You can check checksum here. And here is the reference to login pop-up during login commit. That is commit that we merged from TA304 branch. And we see in parentheses that it is from origin master branch. And we have our own commit which we did in scope of this branch, carousel on the home page. To demo you another option of handling merge conflict and to demo rebase to you, I suggest resetting our state to the state of this commit, carousel on the home page, before we even did a git pull origin master command. Right now you are going to see git reset command, which we are going to learn in the separate lesson. I have to use it in this lesson so that you would keep track of all my changes in the Git repository. I believe that showing all my actions in Git to you is the best way to learn such powerful tool as Git. I will perform the next command and I will explain you in short what it does. Git reset. This command can reset state of your file system to the specific revision. Option hard. Reset command has different modes. We'll learn all possible modes in the separate lesson. Hard means that files from the other revision will be restored and all changes from other revisions will be removed. Head is a pointer to the current place in Git. That is our last commit. -1. This means reset state of our file system to the state that was one commit ago. That is right before we pulled changes from the origin master branch. Let's press enter. And here we are on the carousel on the home page commit. Let's check commit history now. Git log command. Awesome! We can even check our file system. Let me show you that we don't have login CSS file from another branch. cd styles ls-l. And you can see that we only have carousel CSS file and we don't have any login CSS file here. Cool. Let's get back to the src directory. cd /. And now, instead of doing git pull origin master, let me execute another command that we have learned today. Git pull with option rebase origin master. This was expected. In case we wouldn't have any merge conflicts, rebase would be very smooth. But that is way too easy for you. Let me show you how to resolve merge conflicts during the rebasing. I believe you remember that we expect merge conflict in home.html file. But this time we have a bit different message. We see that error happened during the rebasing and commit couldn't be applied. Here Git leaves a hint for you what to do in this case. We have to resolve all conflicts manually. After that, we have to either add or remove files to the staging area and execute git rebase continue command. I don't recommend you skip this commit like it is shown here, because our goal is to resolve conflicts and finish rebasing. In case you understand that you did a mistake and something is going wrong, you can execute git rebase with abort option. By the way, here in parentheses you can see indications that we are in the process of rebasing right now. But let's resolve merge conflicts. nano webcontent/home.html. Let me quickly resolve these conflicts. After conflicts are resolved, I close and save this file. Now, as it was said before, I have to add files to the staging area. Git add dot. And now we can proceed our rebasing. Git rebase continue. Git offers me to adjust my commit message, but I want to keep it the same. Carousel on the home page. That sounds just perfect. So I just close the file. And I see a message that I was successfully rebased on the other branch. Now let me update my branch in remote repository to update my pull request. Git push. Oh, I see error here. Updates were rejected. Why? Because I already had a branch in the remote repository. My origin TA305 home carousel branch has different commit history rather than my local branch now, because rebase command changes Git history, and Git is not smart enough to understand this. For Git, it just looks like a mess. Now our local branch and remote branch has different history of commits. Let's take a look one more time at the history of commits of the remote branch. Can you see these two commits? And can you see commits checksum? Now let's return to git bash and check commits there. Git log -2. Can you see this? We put our carousel on the home page commit right on top of the master branch. That is actually what rebase does. And pay attention to checksum here. Can you see that commit with the same message has different checksum? Okay, we understood that our commit history is different on different branches, but what to do now? I need to tell Git which version is correct. I know that my current branch is the most relevant branch, so I have to update my origin branch so that it would have the same commit history as my local branch. To do this, I need to perform the next command. Git push with option F. F stands for force update. Be extra careful when you do this, because force update will erase changes that are currently present in the remote repository in this branch. If you are going to use rebase command, that means sometimes you would need to use force update option. But, one more time, be extra careful. Use this option only with your branches, only with branches that only you are aware of. Because in case somebody created branch from your branch and you change commit history and your branch was merged, that will cause extra efforts for the engineer who created branch from your branch. Real life example: QA automation engineer who is going to help you with writing UI tests for your home carousel created his own branch from your branch. You updated commit history and merged it to the master. QA engineer can't merge smoothly his branch, neither to your branch nor to master right now without rebasing and solving conflicts one more time. Or imagine that QA engineer merged his or her changes into your branch, and by applying force update he overrides those changes, and your commits were lost. This even sounds complicated, so please try to avoid this. Today we are going to create few rules that will save you a ton of time and your nerves in the future. I call these rules 4 rules of happy work with Git by Andrei Petaha. Rule number 1. Always create branches from the master branch, but not from the other development branches. Rule number 2. Force update only your own branches that you can be sure nobody using. Because of the risk of losing data, force is very risky mode. What is less risky? The rule of thumb is using force with lease option. What is this about? Force with lease is a safer option that will not override any work on the remote branch if more commits were added to the remote branch by another team member. Based on this, let's make rule number 3. When you need to use force update, always use force with lease option. I can't even count how much times this simple rule saved me tons of time. So, we use force with lease option. Let's press enter button. Taking into account nobody updated my branch, I successfully updated my branch in the remote repository and my pull request. Let's check my PR now. Can you see this? I have 1 commit instead of 2. And also, checksum of the commit carousel on the homepage is changed. Now I can use rebase and merge strategy. That is awesome, we did this together. And now it is time for the rule number 4. Rule number 4. Always rebase on origin master branch before creating a commit. Now you know how to rebase on master. I would even say that this is the best practice to rebase on origin master as often as you can, to fix conflicts gradually and to test your implementation on the latest version of the code during the development. To not spend a lot of time when you worked 1 week on your task and after solving all conflicts you realized that feature doesn't work as expected. Okay, we did really a lot today. Let's recap what we have learned today. In this lesson we learned what a rebase is. We understood the difference between merge and rebase. We tried to answer the question what is better to use, git merge or git rebase from different points of view. On a real example you saw how rebase command works. You know when you need to execute git rebase continue command. Also, we learned when we need to use force update mode and how force with list option can help us to not overwrite other commits. And at the end of the lesson we reviewed 4 rules of happy work with Git. We learned a lot today. I'm really happy you saw this lesson. Thanks a lot for your attention, dear students. Have a great the rest of the day and see you in the next lesson. Hello team, in this lesson I'm going to show you how interactive rebase works. Today I will show you when and how you can use interactive rebase. On real examples I will show you how you can change any commit message from your repository history and will show you how to combine 2 commits into one. After this lesson you will learn how to squash commit. I will share with you best practices of working with Git and keep Git history clean. Let's start. And we will start from the example that we had in previous lesson. Imagine that being on the task branch you understood that you have to do one more commit. Probably you forgot to add some styles. For the sake of example, let me adjust carousel CSS file. nano styles/carousel.css. I will just put new lines here to not spend a lot of time on modifying this file. I add these changes to the staging area, git add dot. And now you need to include latest changes into your branch. What you can do? The first option, which we have already learned and which I want to remind you, is to amend the last commit like this. Git commit with option amend with option no edit. This will allow you to change your latest commit without changing commit message. But let's pretend you didn't want to amend commit for some reasons and want to create one more commit. Or you are dealing with commits that were merged into your branch by a colleague of yours who doesn't know Git as good as you are, and that's why you have extra commit for this change. Let me create a commit now. Git commit with option M, CSS class for home carousel slider is added. Okay, and now you have 2 commits on your branch. Let's add one more commit. We need this to have at least 3 commits to play with on our branch. That is for the sake of the demo. The same as before, I will quickly adjust our CSS file, and I will create one more snapshot. nano styles/carousel.css. Adding new lines here. Git commit -a-m one more CSS class for home carousel slider is added. Okay, now we have 3 commits. Imagine that you are not happy with commit message and want to change it. What options do you have to adjust last commit? Git commit with option amend. But what if you don't want to change commit message for your latest commit? What if you want to change commit message that goes right before the last one? Interactive rebase will help you with this. What is interactive rebase? Interactive rebase in Git makes it easy to clean up your commits before they get rebased or moved onto another branch. Git rebase with option I, head, -3. I stands for interactive rebase. We want to proceed with interactive rebase for last 3 commits. That's why I wrote head, that is the pointer to our current state, -3, that means 3 commits back from the current one. Let's press enter now. Awesome! Here we see our 3 last commits, starting from the latest to the newest. And I see that to change message I have to write R letter near the commit where I want to change commit message. And I want to change not the last commit message, but commit message that goes before the last one. So I put our letter next to CSS class for home carousel is added commit message. I save file by pressing Ctrl and S and close the text editor. In this window we can change commit message as we wish. Let's add more details. CSS class for scrolling carousel on the home page is added. Now let's save this file and close the text editor. Here you can see notification that we successfully rebased and updated the branch. Let's check commit history. Git log -3. And we can see that commit message for this commit and checksum of this commit was changed. Great! After we changed the message for commit, we took a look at our branch commit history one more time and realized that it is way too many commits about the same thing. We have 3 commits right now for the one single piece of functionality. We know that in case we would push this change to the remote repository, our tech lead might be disappointed. Why? Because for the one single task, create styling for carousel on the home page, we have 3 commits right now, instead of having one single commit. Your tech lead may ask you to squash your commits in order to keep Git tree clean. What does squash mean? In other words, you can combine 2 or more commits into the one to ensure clean Git history. You can melt commits so they would disappear, but not the changes which were done in scope of these snapshots. Let's imagine the case that during the development of your task you did multiple commits and after that you realized that it would be better to have either one commit or group commits in a bit different manner. How to do this? Interactive rebase will help us also with this task. Git rebase with option I head -3. You're already familiar with this command. You can specify as many commits backward as you want instead of 3. I'm specifying only 3 right now because we all remember 4 rules of happy work with Git from the previous lesson. I can modify only commits that are on my branch, but not commits that already exist in master branch. I press enter. The same commit history as we already saw today with updated commit message. We can see that to combine commits we can use either squash or fix up. We'll use squash when we want to change commit message and fix up when we want to keep commit message of the first commit. Most likely, if you combine multiple commits, you want to reflect this in the commit message. That's why more often you're going to use squash rather than fix up. Important thing to mention here, you can't squash the first commit in the list. In other words, here in the first row you should have peek to be able to squash other commits. I wrote S letter near other 2 commits. S stands for squash, and in case you forgot you can find other shorthands here. I press Ctrl and S to save the file and close it. Now I'm asked by Git to adjust commit message. I see the commented lines and commit messages of my other commits. Let me clean this up a bit and leave the one message which I'd like to keep. In addition to this one, I want to add few words. Is styled. I save the file and close it. I see message that I successfully rebased. What else potentially may happen here? Potentially, you can see message about merge conflict during the rebasing. Similar to the one you saw in previous lesson. Taking into account you combine commits, there might be merge conflicts. But you already know how to deal with conflicts during the rebasing, since we showed this in the previous lesson. Let's check our commit history now. Git log -3. Great! You can see our commit with updated message and pay attention, new checksum. If checksum is different, you already know that push to remote repository will be rejected. Beside our updated commit here, you can see other commits from the remote master branch. And we can't see here our commits where we adjusted CSS file, because they are melted, but the changes are in place. We can open our CSS file just to check this. nano styles-carousel.css. Then find that new lines added in first commit and new lines added during the second commit are in place. We can count number of new lines, but I believe it is even visually obvious. We did all we wanted. And you already know that in case there is a difference between commit history in my local branch and remote branch, we need to force update our remote repository. And on previous lesson you already learned best practices, and we are going to use force with list now. Git push force with list. We added additional changes and combined them in one snapshot and updated our pull request. This will make your tech lead happy on your future project. I promise you. Now let's recap what we have learned today. In this lesson we learned what interactive rebase is. You learned how to start interactive rebase. You saw how you can change any commit message in your repository. After this lesson you also know how to combine few commits together. We learned best practices of working with Git today. That's all for now. Thanks a lot for your attention. See you in the next lesson. Hello dear students, in this lesson we are going to learn in detail what is git reset command and how we can use it. We'll start from the problem statement and when we might want to use it. Afterward, we'll learn in theory how it works. To understand how git reset works, we'll compare it with git checkout command. We'll review 3 different modes how git reset may work: soft, mixed and hard. Besides the theory overview, on a real example I'm going to show you how you may use this command in your repository. Let's start. So, when you need to use git reset command. Git reset command is a really powerful tool that will help you to undo changes. It might happen that you created snapshots that you don't need anymore. Or probably, for some reasons, you want to remove commits from your local branch, but you don't want to remove changes from your working directory. For such cases, git reset command might be used. You can find tutorials on the internet, but in my opinion, they are really hard to understand for the people who have never had experience with Git. That's why in this lesson I will try to explain this topic from the practical point of view to help you understand the topic better. To understand how git reset command works, let's compare it with git checkout command. Here is our master branch, and here is our head pointer that points to the latest snapshot on this branch. So, what happened when we call git checkout command when we try to switch to another commit? We can execute git checkout command with the revision checksum where we want to switch our head pointer. In this particular scenario, if checksum is b, then I can move head pointer by executing command git checkout b. But the master branch is still pointing out to the latest commit here. If you remember, during one of our lessons we discussed detached head state. This is exactly the scenario of detached head. So, what does reset command do that is different from checkout command? In case I will use git reset command with checksum of the specific revision, Git will move both head pointer and current branch pointer to this specific revision. That's what Git always does, no matter what option will be used with reset command. Can you see the difference on this visualization? Hope it is clear now what reset command does. But besides the updating of commit pointers like head pointer and branch pointer, reset command will also update the state of our staging area and update the state of our working tree. That is our files in our file system. Updates in the staging area and working tree will be different, depends on what mode of reset we are going to use. As you learned from agenda, there are 3 possible modes: soft, mixed and hard. Let's learn right now what will happen in case we reset in soft mode. If we use git reset with soft option, we still move head and branch pointers to the specific revision and that's it. Nothing above that. Changes from your working tree will be there and in the staging area. In simple words, the changes that you did in files before resetting commit. These changes still will be present in files of your project. Moreover, these changes will be in the staging area. In case after reset in soft mode you would call git status command, you would find all your changes added to the staging area in green color. Execution of git commit command is going to lead you directly to the state where you were before resetting. Here on this slide you can see that soft mode keeps all changes in the staging area. In case you are going to use mixed option, it is similar to soft with only one difference. Changes still will be present in the working directory, but they won't be present in the staging area. In simple words, you still will be able to find your changes in files, but when you will call git status, you are going to see that all changes are not added to the staging area. You would need to perform git add and after that git commit command in case you want to restore the state before resetting. The previous 2 options you may want to use when you're kind of okay with changes that you have done, but you have to do some modifications in the git history. The hard option for reset is really hard. This is the most direct and dangerous option that is frequently used. After executing git reset command with the hard option, Git will make sure that your staging area and your working tree match that of the specific commit. In simple words, your file system will be the same as it was after commit, which you specified in reset command. When this mode is needed. Personally, I used this command a lot when I realized that I messed up completely the state of my files and I want to get everything back as it was when it worked, at least somehow. Sometimes you might want to reset the state of some specific revision. Probably you want to reset state of your local repository to the state that you have in remote repository. You might want to do so in case something went wrong during the rebasing. Today, during the demo, I will show you how to reset your changes in different modes. Now, when you understood the theory, let's practice a bit and I will show you how you can use git reset command in different modes. We are on the master branch. Let's check our git history. Git log -3. Here are the commits that we did during this course. You remember we added stock management service and created separate snapshot for that? Afterwards we created cart management service file and created separate snapshots for that. And after that, I did create HTML file home.html for our lessons to understand merge conflict topic. Do you remember that? Let me show you, for example, that after soft reset to the state of the stock management commit, cart management service and home HTML are still present in the working tree, but the state of the branch and head pointer is different. Git reset with option soft E71A5B. I entered first characters of this commit and press enter. Let's check our commit history to understand where we are now. Git log -3. You see here in parentheses that our head and master pointers are on this commit. Let me check git status. Git status. And you can see that two files from the two commits are present in my file system and automatically added to the staging area. To return my project to the state where it was before the reset, but with the new commit, I have to commit them one more time. Git commit with option M, cart management and home HTML. And we created new commit with these changes. Now I want to demo to you mixed mode. Let me find command that we recently used and just change it a bit. Here it is. Let me remove soft here. By the way, mixed mode is a default. That means you shouldn't necessarily write mixed here. You can just remove any options here. That would mean resetting in the default mixed mode. Let me check git log now. Git log -3. I'm on the commit where I wanted to be. And let's check status now. Git status. And you can see that files are present in my working tree, in my file system, but they are not in the staging area. Can you understand the difference between soft and mixed mode now? To return the previous state, I should execute git add dot command and after that commit changes. Let's use the same commit message as previously for the sake of the demo. Awesome! And let me show you the last but not the least option, hard. Let's reset in hard mode to this commit. Spaces are added to the hello world file. We should see how the state of our file system will be different. Home.html, cart management service and stock management service files would disappear. Git reset with option hard 26726F. Let's check commit history now. Git log -3. Okay, our head pointer and branch are pointing to the commit that we expect. But what is with our file system now? Git status, and we can see that there is nothing to commit, and that is my working tree clean. I'm in the src folder right now. Let me check the state of the file system. ls-l. We can see that I have only discount calculation service and hello world file. I don't have neither cart nor stock folders where my other files were stored. Now you can see how a git reset with hard option can reset the state of the file system. One more trick. Probably in some lessons you saw that I reset state of the branch without referencing to the specific commit checksum, but using relative navigation from the head pointer. Let me show you one more time. Git reset with option hard head -3. You can see how I can move head and branch pointers to 3 commits back from the point where I was. This is pretty convenient as for me. Probably you would also use this variation of reset command. And one more real life scenario. Imagine that you wanted either to squash commits or a word message, or something else went wrong during the rebasing or during the development and you want to reset the state of your working tree, your file system, as it is in remote repository right now. What I recommend you to do. The first thing that I always do is execution of fetch command with all option like this. Git fetch with option all. This is just to make sure that you fetch the latest state of the remote repository. After that, reset with the hard option to the state of origin branch. In this particular case, we played with our master branch, and I want to restore the state of origin master branch. Git reset with option hard origin/master. And you can see that I'm on the latest commit right now. Today you saw that in reset command you can use commits checksum, relative amount of commits from the head pointer, and even specific branch. I believe now you know about reset command even more than some senior software engineers. Hope you enjoyed the lesson. Let's recap what we have learned today. Today we learned what is a git reset command and when we can use it. We understand the difference between git checkout and git reset command. You learned 3 modes of reset command: soft, mixed, and hard. On the real example you saw how to reset state of the branch few commits back from the head pointer or to the specific commit. Also, you learned how to reset state of the branch to the state of the branch in the remote repository. That's all what I planned to talk about in this lesson with you. Thanks a lot for your attention and see you in the next lesson. Hello dear students, in this lesson we are going to learn with you git stash command. I'm going to tell you when you might need to use it. You'll understand how to reapply changes from your stash. On real examples I will show you how to manage multiple stashes and even how to create a branch from your stash. And also we are going to learn different commands that will allow you to clean your stash and to perform other operations with it. Let's start. First of all, let's understand potential problems that stash command may help us to resolve. Imagine that you're sitting at your computer and work on some task. And all of a sudden, you receive a call from your manager. Your manager screams that you urgently need to fix some other thing or you have to start work on the other task immediately, but you didn't finish your current task. Your manager told you that you have to give up everything and start work on the new task. The state of your file system doesn't allow you to create a commit right now. Probably because you even can't build your project successfully, or you are just in the middle of something important to finish. And it looks like that you have to put all your changes aside to get back to them later. Hope that you understood the problem and real life case that may happen with you almost on daily basis. But how to address this issue with the help of the Git? Git stash command will help us with this. Stashing takes the dirty state of a working directory, that is your modified tracked files, staged changes, and saves it on a stack of unfinished changes that you can reapply at any time, even on different branch. What a stack is, I will explain a bit later. Don't worry. I believe that the best way to understand how git stash command works is to show it to you in git bash. I am on the master branch right now and my working tree is clean. Let's imagine I am in the process of implementation of some important task. I create new branch. Git switch with option C TA306 important task. Okay, and being on this branch in src folder I modified home.html file. To not switch the windows between different code editors, let me do small changes right here in the terminal using nano text editor. Nano web content /home.html. I added some important changes here. P, some important line, P tag is closed. After I did all my changes, I saved the file. And now I've received message from my manager who is in panic and asks me to start work on the super important task. I don't need changes from home HTML file that we have just created during another task implementation. Let me check status of my branch. Git status. And you can see I have one file modified. And currently it is in the state when creating snapshot with it doesn't make a lot of sense. So I will put it temporary in my stash. How? Simply by executing the next command, git stash. Great, now our changes are in stash. Let's check status one more time. And you can see that right now it is nothing to commit. But now I can be sure that my changes won't disappear. I am returning to the master branch to create the new branch, git switch dash. Here I create a new branch, git switch with option C TA307, super important task. Okay, and now I can continue work on my new important task. My changes that are currently in stash are not present on this branch. Let me show you this. Nano web content /home.html. And we can't find our important line here. Cool. Now, let's imagine that you realize that you need those changes here and you need them back. How get your changes back from stash? You need to apply changes from your stash. To do this, let's use the next command, git stash apply. And instantly you see the status of the branch and indications that home HTML file is modified. Let me open it to double check. Yes, I see my important line here. Awesome! Now, important information about stash. This command creates stack of changes. Do you understand how a stack of changes may look like? Let me show you quickly. In computer science, stack is an abstract data type that serves as a collection of elements. It works according to LIFO principle. One more fancy word. What does LIFO stand for? LIFO is an acronym from last in, first out. This is method of storing data in data structures according to which the last element get into the container, leaves the container the first. And on the screen you can see visualization of stack. Imagine that each element here is a separate batch of changes. When you use git stash command, your changes are on the bottom of this container. When you use git stash apply command, the changes from top of the stack are applied to your branch. And if you use git stash command multiple times, the new changes will be on top. Does it make sense? Now imagine that you used stash command multiple times, and you have a lot of changes in your stash stack. How to view all changes that you have in your stack of changes? Let me show you. To list all changes that you have in your stack, use the next command, git stash list. And specially for this lesson I prepared few items to have multiple elements here. You can see that our last stash has index 0 and it is on the top of our stack. That means you can apply it on different branches. But probably you may be wondering how to apply other changes from the stack. For the sake of the demo, let me apply changes from this stack with the index 1. Git stash apply, and after that I will use the name of the stash that is specified here. Stash add and 1 in curly brackets. Before I press enter, I want to warn you that you are going to see error message. I press enter, and as I promised, here is the error. Don't worry, everything is under control. I did this on purpose to show you this error message that you may see sometime. Git sometimes will show you this message to warn you that your changes might be overwritten after some specific operation, and this is one more case to use stash as a temporary storage for your changes. I already have these changes in my stash, so let me just commit them. Git commit -a-m commit. Sorry about this commit message, just don't want to spend time on the details that we already discussed. Hope you understand that such unmeaningful commit message is not the best practice, and I use it only for the sake of the demo to not lose the focus from the git stash command. Now, when I created a snapshot, let me try to apply one more time all the changes from the stash. And you see that some changes were applied here, namely, login CSS file was removed, and changes in home HTML file were also applied. There is even a conflict in this file since it was modified in different versions. You just have to open this file and to resolve conflicts. For the sake of the demo, let me reset the state of the current branch to its origin state. Git reset with option hard to the head pointer. Let's talk about another problem. Do you remember what is in my stash list? Let me show it one more time. Git stash list. How do you think? Will I remember that there are changes in home HTML file in this stash tomorrow? Or in a month? That's why usually it is a good practice to give a name to each stash. Let me do some changes in the repository. For example, let me remove login CSS file. rm style/login.css. rm is a standard command in Linux terminals to remove files. Let me stash my current changes with a specific message. Git stash save login CSS is removed. And let's press enter. Now, when I will see the stash in the future in my stash list, I will instantly understand what changes it contains. Git stash list. And here I can see my last stash. And it is on the top of the stack. Great! Okay, now let me explain you one more thing. Probably you noticed that I applied different stashes, but they are still in my stack. How to apply stash and remove it from the stack? For doing this, you have to use pop command instead of apply like this. Git stash pop. We see that I applied my last stash and login CSS is removed. Let me check my stash list now. And now you can see that it is disappeared from here. Let's move on. One more thing that we didn't discuss yet is that you can stash only changes that are in the staging area or changes that were done in files that are tracked by Git. Imagine that we created a file and after that we were interrupted. We have to stash it. Let me quickly create a file here. Touch some important file .java. Right now this file is untracked by Git. Let me show you this. Git status. And in case I would try to stash changes, only removal of login CSS will be stored. Let me prove you this. Git stash. And now let's check Git status one more time. And you see that my new file is still in untracked state and is not in the stash. How to add it to the stash? We have to use special option for that. Let me show you. Git stash with option U. U stands for untracked files. Instead of U, you can use A option. A stands for all. Beside untracked files, it would also stash files that are ignored according to our gitignore file. But I doubt that you would ever wanted to include ignored files to your stash. That's why let's use U option here. I press enter. Let me check Git status now. Git status. Awesome! Finally it looks like our new file was stashed. And now imagine that you want to create a branch from your stash. Imagine that when you finished work on the super important task, you already removed all old branches and you have to create a new one. How to create new branch from stash? Use the next command. Git stash branch TA307 new. You can specify here any stash ID you would like. Without specifying stash ID, the first stash from the stack will be used. And you see that I have new untracked file on my new branch. Git also moved me to the new branch. You can see it here in parentheses. And what to do in case you don't want to apply your stash, but you just want to remove it? Use the next command. Git stash drop. You can specify any stash ID here, for example, stash at 0. Now let's check stash list. Git stash list. And you see that our first stash in stack was removed by us. In case you want to clear all stack of stashes, use the next command. Git stash clear. And in case we would check our stash list now, we are going to see nothing. And here's empty list. Nothing is here. Great! It looks like that is all what I planned to share with you in this lesson. Let's recap what we have learned today. Today we learned what a stash is. Now we know how to use git stash command. On real examples we learned how to manage multiple stashes. We learned how to stash untracked files and how to clear your stash if needed. We also learned what is the difference between git stash apply and git stash pop. That's all for now. Thanks a lot for your attention. See you in the next lesson. Hello team, today we're going to have super interesting topic. In this lesson I will show you how you can restore literally everything what was ever present in any snapshot in Git, even if it was overwritten either by force push or hard reset. Today we will learn such command as git reflog. We are going to understand when and why we have to use it. We will imitate cases when we lost some changes and we need to restore them. After this lesson you will be able to use reflog command with different options and variations like a pro. You are going to learn how to restore lost commits in the new branch, or reset current branch to the commits that were lost. Let's understand first, why do we need to use reflog, and what problem it may help us to solve. It may happen that at some point during your Git journey you may accidentally lose a commit. Like I told you before, it may happen during the forced delete of your work or during the hard reset. or you used interactive rebase to squash commits and resolving of conflicts during the rebasing went wrong and some changes were lost. So how to get lost changes back? In Git, if something were ever committed, might be restored. Git won't be able to restore files that were never in the staging area and were never committed before. I suggest starting learning of the Git reflog directly from the practical exercise. Let's start. To show you how to restore changes, let me intentionally lose some data. I'm on the master branch. Let me show you latest commits. Git log -3. Let me hard reset 2 last commits. Git reset hard head -2. Okay, the branch is reset. Let's check commit history. Git log. Now we can say that we lost 2 commits. Okay, there is no harm for me to restore the changes from the origin branch, but it might happen that the origin branch was also accidentally overwritten or completely removed. You won't believe me, but such cases may happen. At the first glance, it looks like that I only need to remember the checksum of the lost commits, but we didn't memorize them, agree? The most complicated in this task to learn checksum of those commits, and the easiest thing to answer this question is to call git reflog command. What is a reflog? As we are working with Git and moving pointers, Git silently records what is our head pointer and how does it look like. That means that each time we either creating a new snapshot or switch branches, the reflog is updated. You can investigate the history of all changes in your repository by executing the next command, git reflog. We can see information about each operation that was done here, about each commit, each reset on origin master branch. You can find information here about different branches by the reference in the parentheses. Also, you may find checksum of each state right here. By the way, this is the last program. This is a program for text terminals for Unix-like systems. To close it, just press Q key. To remember it, Q stands for quit here. Let me press Q. Okay, you already saw where's the place where you can get checksum of the commits that you want to restore. I know that for some students the way how reflog looks like is not very informative. We can't see the detailed commit messages. We may find only description of the operation but not the details about the commit. What would I suggest to you is to use the next command, git log with option G. Here you may find list of all commits with the reflog reference. Here is our commit that we have lost. Let me create a new branch with the state of that snapshot. Git branch lost changes. And now I have to specify commit checksum that I want to restore. E50BAD. Great! Now let's check commit history. Git log lost changes. Just to remind you, to check the commit history of the specific branch, we should specify branch name next to log command. And we can see that our new branch contains commits that were lost. So, as far as you may understand, you can restore anything what was present in any commit in your local repository, or anything where head pointer of your local repository ever pointed to. Also, one more important note. By default, information in reflog is stored for 90 days. Usually it is enough. It is very unlikely that you lived your happy life for 91 days and after that realized that you need to restore some lost commit. Let me show you one more syntax of restoring changes. I'm on the master branch, and I didn't switch to the new branch with the name lost changes that we created with the lost commits. On the master branch, I still don't have my lost commits after the hard reset. Let me reset with hard 2 more commits back. Here is our git reset hard. To prove you that we really moved few commits back and that we have lost even more commits, let me show you commit history. Git log -3. And you can see that we lost our E50BAD commit. Let me show you reflog one more time. To not show the whole reflog, let me show you the reflog only for the past 1 hour. Git reflog with option since equals to 1 hour. And I see limited amount of reflog. You can use day instead of hours if you wish. So here is the state of our head pointer before reset. It has index head, @, and true. Let's reset state of the current branch to this position. Git reset with option hard, head add to. And let's check our commit history one more time. Git log. And here we are. We successfully restored state of our file system and state of our branch that was before the last reset. I believe this information will help you a lot in the future. That's all what I planned to share with you today. Let's recap what we have learned today. So today we learned what a git reflog is. Now you know how to use this command. During the lesson we restored our lost commits by creating branch from the lost commit or by resetting the current branch to the previous state before some commits were lost. Also, we learned how to show reflog filtered by time passed. That's all what we have for today. Thanks a lot for your attention. See you in the next lesson. Hello team, today we are going to discuss with you one more important command that may help you to modify commit history. Today we'll talk about cherry pick command. As usual, we'll discuss when we need to use this command. After we'll understand when we need to use cherry pick command, we'll proceed with our practice exercise to understand how we can use it. In this lesson I will share with you my experience of using cherry pick, and I will tell you why this command is not considered as a best practice, and even despite that, why we may need to use this command sometime. I am going to teach you how to cherry pick multiple commits at once and how to resolve conflicts during cherry picking. And at the end of the lesson I will share with you best practices of using cherry pick. So, when we have to use cherry pick? There are different cases when you might want to use cherry pick command. Some of them. Deliver hotfix to the end user as fast as possible. Imagine that you created release branch. Release branch should contain only source code that is going to be part of the build of your application that is going to be deployed on your production environment, where it will be available to the end user. And imagine that you realize that during rebasing or merging of the latest changes before creation of the release branch, you missed important change and now you have a defect in the release branch. The fix for this defect is present in the snapshot in your feature branch. It was tested, it was approved. So, the only thing that you have to do is to move the commit from the feature branch to your release branch. And to move one snapshot from one branch to another, we have to use git cherry pick command. Or imagine another case. Undoing changes and restoring lost commits. Not all branches are merged into the master branch, and some commits might be lost. Using git reflog command, you may find snapshots that you need and cherry pick it into your branch. One more scenario. Regular team collaboration. In case you and team members work on the same feature and you have some shared functionality, you may want to test something on your branch that includes other changes. For example, backend engineers created a data structure that frontend team also needs to use, and frontend developers may use cherry pick command to get those changes into their branch. Probably during the life of the developer, you will find other real-life cases when you may use cherry pick command. But I believe you understand why you may want to use it. And now attention! I don't want you to share with your tech leads information that Andriy Petaha told you that using of cherry pick is the best practice. I want to say that cherry pick command usually considered as not a good practice, and regular merges are preferred instead when it is possible. But sometimes you may want to use this command. Why git cherry pick is considered as not a best practice? Notice, I said literally consider it not as a best practice, but not necessarily the bad thing. To understand this, let's review how git cherry pick works. It creates, attention, separate commit with different hash and has no reference to original commit. Content of commit will be fully duplicated, but Git will consider new commit and original one as two different commits. That's why some developers may consider cherry pick as a bad thing, because it may cause problems like having duplicate commits in multiple branches, messing up with Git history and others. But in case you are using this command attentively, there is no harm in it. For example, there might be cases when you can't merge some branch because it contains a lot of other changes that are not needed anymore. And at some specific moment of time you need only one single commit. That's where cherry pick command may help you. So, use cherry pick with caution. At the end of the lesson we are going to summarize rules that you have to follow during the cherry picking. Now, let me show you the real example of cherry picking in Git. For this lesson, for the sake of the demo, I prepared a branch with few commits. Let me briefly explain you the state of my current repository so that you would understand the example. Imagine that I am working on the implementation of login functionality, and I created separate branch for that with the name TA308 login. You can see that I am currently on it. Let me show you the commit history of what I have already done. Git log with option 1 line -3. The option 1 line allows me to format output in a bit different way than usual. I press enter. Here what I have already done while being on this branch. I implemented styles for login button. Also I implemented backend part of login feature. And here is a snapshot of the origin master branch. And imagine that during the testing of my work, quality assurance engineers found a lot of defects. And we are not in the position to merge my branch TA308 into the master branch. But everybody really liked the styling of my login button. And product owner requested to have the other buttons in the same style. That's why I want to prepare a pull request for only styles of my button, and we'll merge that branch into the master so that other developers also would be able to pick up that changes while I will be fixing all the defects with backend code for the next week or two. Just joking, you know that I would fix it faster. But just as an example. This shouldn't be a problem because I will rebase my branch with the backend code on the master before merging. Or even just remove styling snapshot from the current branch. Do you understand the real life case? Let me now show you how to do that. First of all, let me create the branch from the latest master branch. Git switch master. Git switch with option C TA309 button styles. Okay, I am on the new branch. And imagine that I did some changes in the login CSS file. Just did any random changes. Nano style /login.css. Let me write here some text. Some changes. And save it. Now let me commit this. Git commit with option A and with option M, some commit. I press enter. And now, being on this branch, I have to cherry pick this commit with checksum EC6B5EC. To copy that commit and apply it on my new branch, let me execute the next command. Git cherry pick EC6B5EC. In case we wouldn't adjust the login CSS file, we won't see conflicts here and your commit would be applied. But that is way too easy for you. I wanted to imitate state of the conflict during the cherry picking to show you the process of the conflict resolving during the cherry pick. You see that Git indicates that we are in the process of the cherry picking, and Git gives us advice to resolve conflicts and add files to the staging area. Let me check Git status. And you see here in unmerged path, it is said that there is a conflict in login CSS file. So let's open it in the editor and let's resolve the conflicts. Nano styles /login CSS. We'll imitate the fact that we resolved all conflicts. Now let's mark this file as resolved. Git add dot. Now let's continue our cherry picking process. To do this, let's perform the next command. Git cherry pick with option continue. And Git allows us to adjust commit message. By default, it keeps the origin commit message of the previous commit. Let's save and close this file. And we can see that we applied our changes here. Let's check our commit history. Git log with option 1 line -3. And here's our new commit. And attention, in case you would compare checksum of this commit and checksum of original commit from TA308 branch, you're going to find that they are different. That means that these two are not the same commit. This one is just a copy of the first one. And now, few more important variations and options of cherry pick command. In case something went wrong during the conflict resolution, you can just abort the process of cherry picking like this. Git cherry pick with option abort. Also, if you wish, you may cherry pick multiple commits at once. To do this, just specify checksum of all commits separated by space like this. Git cherry pick EC6B5EC and 3F31666. Those are two commits from our demo. Now, when you know how to use cherry pick, let's talk about the best practices. The rule number 1. If it's not critical and you can apply necessary changes with merge, opt for merge option. It is considered to be a general practice to prefer merge option over cherry pick. Rule number 2. Avoid creating any duplication by using cherry pick. If you cherry picked commits and removed old branch or just reset the old branch, that's fine, and this will not lead to any issues. Potential issues may happen in case you keep two branches and have duplicated commits. Rule number 3. Sometimes it is considered as a good practice during the cherry pick to specify the hash code of the original commit. Git may help you to do this in case you will use X option like this. Git cherry pick with option X. This option will automatically add the information about the original commit into your new one. And here on the screenshot you may see how your commit message will look like. You learned a lot today about cherry pick. Let's recap what we have learned today. Now you know when you may need to apply cherry pick command, because we discussed with you different cases when this command will help you. Also, you understood why cherry pick is not considered to be as a good practice. On real example you saw how to resolve conflicts during cherry picking. Now you know how to cherry pick multiple commits at once. And at the end of the lesson we learned best practices of using cherry pick command. That's all for today. Thanks a lot for your attention and see you in the next lesson. Hello dear students, in this lesson we are going to discuss the topic that will be interesting for developers who work in such integrated development environment as Eclipse. We are going to learn today how to integrate Git with Eclipse for development comfort. Besides the Git buttons and widgets that we'll configure in Eclipse during the lesson, I will show you how you can use Git bash directly from the Eclipse. Together, on real example, we are going to learn how to execute basic Git operations from Eclipse. I'll make overview of widgets that will allow you to see Git history, navigate between branches, push and pull changes from the remote repository. After this lesson, you will learn how you can resolve conflicts in Eclipse interface. Let's start. And to learn the topic, I suggest jumping to the practice. Here is my Eclipse workspace. I created completely new workspace and reset perspective view to default to configure it with you from scratch. I have imported the Java project which we did together during the learning of the Git in the workspace. How to import projects into Eclipse I am going to show you in the separate lesson, to not lose focus from the Git topic right now. When I imported the project, Eclipse automatically recognized that there is a Git repository. And you see that in square brackets it is even specifying my current branch. But nevertheless, I will show you how to add your Git repository to Eclipse manually, just in case. First of all, let's add all views here that we need. Click on Window, Show View, Other. Find here Git folder or use search bar to find it faster. I would say that Git staging and Git repositories, those are two that you need 100%. Well, at least in my opinion. I'm holding Ctrl button and with mouse left click selecting the options that I need. Let's also select Git reflog. And it is good that we have learned how to work with Git in the Git bash. At least now you already understand what all these views are about. You already know what is the staging area, what is the Git reflog, you already know what the Git interactive rebase is. After we selected all views we need, let's press Open button. Nice. Views were opened. Just to remind you that you can move these views wherever you like the most here in Eclipse. For example, let me move Git repositories widget here at the bottom with other views. And you can see that my Eclipse recognized Git repository in my project automatically. But just for the future and just in case, I want you to know how to add existing repositories to the Eclipse. Because it might be that Eclipse will not automatically recognize that you have .git folder in your project, and in this case you have to add it manually. For the sake of example, let me remove the Git repository from this view in Eclipse. Mouse right click, remove repository from view. Because I want to remove Git repository only from Eclipse view, and I don't want to remove the .git folder from the file system. And I don't want to remove the project in Eclipse associated with this Git repository. I want to keep project in my workspace view. That's why I press this button. Awesome! Now we don't have any repository here. You can create a new repository if you wish, that is similar to executing git init command. You may also clone existing repository with the help of the Eclipse wizard, and in case you already have Git repository on your computer, you can just add it to the workspace. I believe there is no need to go over each of these options in detail, because creating a Git repository is just specifying directory where you want to create .git folder and pressing create button. Cloning repository is just specifying the path to the repository and your credentials in case you will clone repository with the help of HTTPS protocol. But from my experience, this option, add an existing local Git repository, is used most of the times by me. And I don't know why. Probably because I don't rely on the Eclipse tools to manage my Git repository. Usually I fetch all projects with the simple git clone command in the git bash, and after that I'm importing project to the Eclipse and adding an existing local Git repository. Personally for me this option is the easiest one. But my job is to share with you all possible options and let you decide what works the best for you. That's why let me show you how I usually add existing local repositories to Eclipse. And now you should specify a folder where your local repository is located. I navigated to the folder that we created together during the course while learning Git and press select folder button. Here Eclipse shows me repositories that it found in this folder. I check this checkbox and press add button. And here's my repository back again. Let me expand it. It is very convenient to switch branches here. You may find here local and remote branches. Double left click on the master branch will move me to the master branch. Eclipse will ask your confirmation. Just click checkout. And you already know how git checkout command works. So, I believe you understood what happened behind the scene. And you may see small tick here next to the master branch name. Let me switch back to the TA309 branch. Right click on the branch would allow you to do the operations that we learned to perform in git bash. You may reset branch in different modes, soft, mixed and hard. You may rebase your branch if needed, merge, delete, rename and perform all other operations that you may perform in the git bash. We don't have tags in our repository yet, so it is empty here. What a tag is will be discussed in the separate lesson. Here you may find your main references in your repository. You may check out there if you wish. In remotes, you may check to what remote repository you are connected right now. In stashed commits, you can explore the state of your stash and your working directory that is technically your project. Let me collapse everything here. Based on my experience, I mostly use this section to navigate between branches, create new branch if needed and remove old branches. Let's move on. This sign near the repository name means that I have some unstaged changes. You may find similar sign here in the Package Explorer. How to identify what change are we talking about? Let's check separate tab for that, Git Staging. Here you can manage what is in the staging area, write your commit message and commit changes if you want. You also can commit and push to the remote with a single button click here from this view. I see that .project file is marked as unstaged changes here. This is configurational Eclipse file that Eclipse created after we imported the project into it. Let me update gitignore to just ignore this file. I can't find gitignore file in the Package Explorer view, but let me open Navigator view for that. I click Window, Show View, Navigator. In this view I can see all files as they look like in my file system. And here's gitignore file. Let me add here .project and save the file. And you may see that instantly .project file is gone from unstaged changes and gitignore appeared. You can press this green plus sign to add all files from this section to the staged changes section. Let's write commit message. Eclipse files ignored in Git. I can make a commit by clicking here, but probably I would commit and push changes to the remote repository simultaneously. To do this, I have to click commit and push button. Here in wizard, you should set upstream branch for the current branch. That is exactly what we did when we specified U option during the push to the remote repository. Just click all these buttons until you see confirmation that your changes were pushed to the remote. We may check GitHub, but believe me, changes are there in the remote already. Let me show you a few more things. You can press mouse right click on the project and here you will find Team section. This section is integration with Git in Eclipse, and you may find here a lot of different options like fetch from upstream, push or pull changes and many others. Take your time to investigate this section and ask me in case you have any questions. To check commit history, you can press show in history. Here you may see commit hash, commit message, author of the commit and date of the snapshot. In this window you can check what files were changed in scope of the particular commit. You may open the file to see the difference before and after the snapshot to understand what exactly was changed. This is very useful tool during the investigation of the defects when after specific commit something went wrong. Also, here in the Git history you may reset your branch to the specific commit or check out there. Just click mouse right click and select exactly what you need. Now, I want to show you a few more configurations that I found extremely helpful. I want to tell you how you can add few buttons here on the toolbar. Click Window, Perspective, Customize Perspective. Now, go to the Action Set Availability and select Git here. After that, go to the toolbar Visibility and make sure that Git is selected here. Click Apply and Close. And now, here on the top you have very convenient buttons. No matter what you want to do, push, fetch from upstream, pull, check out to branch, rebase, merge or reset, you can start these operations simply by clicking the right button in the toolbar. And even in case you can't find either button that you need, or you want to execute some specific command with a specific option, you always may open Git bash directly from Eclipse and start working it. To open Git bash in Eclipse, find the icon of the console in the toolbar. Here it is. Click on it and select Git bash in the drop-down here. Git bash should be installed on your computer. In other case, you won't be able to find it here in the drop-down list. Now you may click OK button, and terminal is opened. Important thing to mention here, always pay attention to the directory where Git bash is opened. In case you have multiple Git repositories in the single Eclipse workspace, Eclipse may open you another directory. Or it may open you your home directory. To make sure that Eclipse will open to you the right directory, I always press the project first here, and only after that I click Open Terminal icon. Hope this information will help you. That is practical tip that is really helpful to students in my opinion. We didn't talk about reflog yet, nothing special here. I believe you already learned in the separate lesson what a git reflog is. Here you may find the reflog. If you would do mouse right click, you can find additional options that might be useful for you. And the last thing that I wanted to share with you today is to show you how you can resolve merge conflicts in Eclipse. Especially for that, I prepared separate branch where I reproduce merge conflict state. How to reproduce and what merge conflict is? Please feel free to learn in the separate lesson dedicated to the merge conflicts. In this lesson, I will put a stress only on the Eclipse tools to integrate with Git. Here is a separate branch with the merge conflict in it. I called the branch merge conflict demo. Usually, when you have merge conflict, Eclipse highlights to you files in which you have merge conflict with red dots like this. So now it is impossible to miss file with the merge conflict. When we open file, we see the Git signs where Git separated for us different state of the file from different snapshots. But Eclipse offers special tool to merge conflicts in files. Let me show it to you. Mouse right click on File, Team, Merge Tool. Here on top you are going to see commits hash that have conflict. Usually you can't edit text in the window on the right, but you can modify text in the window on the left here. You can click this arrow to place everything from the right window to the left window. When you are going to have more conflicts, there will be different arrows for each specific conflict. And after you modified the file on the left, you can press Ctrl and S to save the file. If we would check the same file in the text editor, we are going to find that all signs that Git put here are removed. Great! In the Git staging, you can put file to the staging area to mark conflict as resolved. When conflict is resolved, you may see small asterisk on the file. And after all conflicts are resolved and there are no more red dots, you can open Git bash and continue either rebasing or cherry picking, something what caused the merge conflicts. I believe we learned a lot today about Eclipse and Git integration. Now, I want you to take your time and click as much Git related buttons as possible to learn the material better. The best thing to learn this is to practice as much as you can. Meanwhile, let's recap what we have learned today. Today we learned how we may interact with the Git with the help of Eclipse. We learned what views in Eclipse we may use to execute Git commands. Also, today you saw how you can execute basic Git operations from Eclipse. Besides the Eclipse configuration, we also learned how to use Git bash directly from Eclipse. Today we even did a commit and pushed that snapshot to the remote repository. And at the end of the lesson, I showed you how you may use merging tool in Eclipse. Hope you enjoyed the lesson. Thanks a lot for your attention and see you in the next lesson.